with us, and many are available on Facebook Live. Those who could not connect here, galaxy of delegates available with us, namely Dr. Anil Roy Dubey sir, Professor Ashok Shukla sir, Professor Yashwant Shukla sir, Honorable Vice Chancellor sir, Professor Talal Yusuf from Australia, Engineer Shivam Tyagi from USA, Engineer Piyush Tiwari from USA, Dr. Polkowski from Poland, Professor R.N. Rai sir, इन सभी को मैं देख पा रहा हूं. Myself, Professor Ramapati Mishra, Director, Institute of Engineering and Technology, salute you all from the land of Ayodhya. And to start with program, we will play Saraswati Bandana to pay respect to Goddess Saraswati. I request my team to share the screen.
शंकर प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा. विचारसार परमा आद्यां जगद्व्यापिनीं वीणा पुस्तकधारिणीम् अभयदा जाड्यान्धकारापहा. हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्.
Buddhim Pradam Shardam. That was salutations to Goddess Saraswati as per the customary. Now we are having Kulgeet in the praise of our university, describing its location and grandeur of our Ayodhya. I will request my team to share the screen for Kulgeet.
Okay, sir.
यही है ज्ञान का मंदिर, कला विज्ञान का मंदिर, हमारा विश्वविद्यालय अवध की शान का मंदिर. यही गंगा यही यमुना यही है भारती वासर, त्रिवेणी है यही अपनी, मिले हैं सत्य शिव सुंदर.
यही तीर्थ यही संगम यही भगवान का मंदिर. यही है ज्ञान का मंदिर, कला विज्ञान का मंदिर.
हमारा विश्वविद्यालय अवध की शान का मंदिर।
हिमालय से उतर सरयू बहाती पुण्य की धारा, लुटाता ज्योति का सोना जहाँ सूरज थका हारा।
जहाँ श्री राम का घर है, जहाँ हनुमान का मंदिर, वही यह ज्ञान का मंदिर, कला विज्ञान का मंदिर। हमारा विश्वविद्यालय अवध की शान का मंदिर। कथा रघुवंश की कहते, जहाँ के धूल के कण कण, जहाँ की राजधानी राम के साम्राज्य की पावन।
वहीं पर है बना यह राष्ट्र के उत्थान का मंदिर, वही यह ज्ञान का मंदिर, कला विज्ञान का मंदिर।
हमारा विश्वविद्यालय अवध की शान का मंदिर।
कभी गूंजे जहाँ पर बौद्ध जैनों की अमर वाणी, जवानों और मुगलों की कला की भूमि कल्याणी।
यही काबा, यही काशी, यही इंसान का मंदिर, यही है ज्ञान का मंदिर, कला विज्ञान का मंदिर। हमारा विश्वविद्यालय अवध की शान का मंदिर। अमर शिल्पी हुआ तुलसी, बनाकर काव का पुष्कर, बने सोपान जिसमें 7 सुंदर 4 घाटों पर।
जहाँ निर्मित हुआ वह राम के आख्यान का मंदिर, वही यह ज्ञान का मंदिर, कला विज्ञान का मंदिर।
हमारा विश्वविद्यालय अवध की शान का मंदिर।
यही है सत्य का मंदिर, यही है न्याय का मंदिर, यही तप त्याग का मंदिर, यही स्वाध्याय का मंदिर।
शिखर यह शंभु के कैलाश का कल्याण का मंदिर, यही है ज्ञान का मंदिर, कला विज्ञान का मंदिर। हमारा विश्वविद्यालय अवध की शान का मंदिर, अवध की शान का मंदिर, अवध की शान का मंदिर।
अवध की शान का मंदिर. That was describing the glory of my university, Dr. Ram Manohar Lohia, Awadh University, located in Ayodhya. Now I will request Head of Department, MCA, to welcome all the delegates and introduce to the viewers. Welcome, Dr. Brajesh Bharadwaj.
Thank you, sir. Best regard, all of you. Good morning, Honorable Vice Chancellor, Professor Manoj Dixit, sir, Pro Vice Chancellor, Professor S.N. Shukla, sir, Dean of Commerce, Professor Ashok Shukla, sir, Aryan Rai, sir, Director IT, Professor R.P. Misra, sir, all speaker, ladies and gentlemen, faculty members and dear students, welcome to all of you. I am pleased to welcome you to the international webinar on next generation computing system. Engineers have taken a major step towards creating computers
Director sir.
I think his internet is not working. I will be moving further. I welcome on behalf of IET all the students and faculty members, all the delegates and participants. I am director of IET, and this international program is to be introduced by me. That is the task given by my team. This international seminar on next generation computing systems, I would like to tell my students that presently we are in the 5th generation of computing system. It started with vacuum tubes, making it the first generation, then went with the discovery of diodes and transistors as a second generation, then with the integrated circuits, made it third generation, then microprocessor made it fourth generation. Now, 5th generation is based on parallel processing hardware and artificial intelligence softwares. What is going on with this generation is known as starting of Internet of Things, artificial intelligence, and machine learning. Computational intelligence has 5 main paradigms at present. That is artificial neural networks we have, evolutionary computation, swarm intelligence. I will be describing it more in due course of time. Swarm intelligence, artificial immune system, we have fuzzy system, which are used to solve the problems in the fields of robotics, speech analysis, we are working with medical sciences, we are applying with automobiles, like driverless cars we are talking about nowadays, computer vision, like night vision systems. Research and industry are exploring radical new computing paradigm such as quantum computing, we learn biologically inspired computing, that also we will be discussing, and many speakers have come as expert on this field. Nano computing, optical computing, these are to name few. New challenges coming out in computations are emerging as a challenge for the engineers and scientists. Biosciences, healthcare, financial services, energy sector. These are the new coming up challenges where next generation computing is likely to find the applications. In the last 3 months, I have gone through some useful information, and I would like to share with all my audience that first of all, I must tell you that COVID-19 is going to take over as pandemic was first informed by our artificial intelligence led health map software, not by any other human being. I must say that 30 December 2019, international alarm about the COVID-19 pandemic was sounded first by a computing system application, Health Map, a website run by Boston Children's Hospital using artificial intelligence and data mining to scan social media. This data mining program computed a news report of new type of pneumonia in Wuhan, China. It is scanned and found so much news from this city of Wuhan that it red alerted by grading it on a scale of 5, giving it 3 marks. It was in the red alert. That is why, and by humans, if you say, it is 30 January 2020, COVID is named as pandemic, and of course, on 11th February, World Health Organization gave it a name of COVID. आर्टिफिशियल इंटेलिजेंस के ही कारण ऑनरेबल प्रेसिडेंट ऑफ अमेरिका ट्रंप साहब कहते हैं कि हमसे चाइना ने ये जानकारी छुपाई और वर्ल्ड हेल्थ ऑर्गेनाइजेशन ने भी गुमराह किया। दूसरा, नेक्स्ट जनरेशन कंप्यूटर सिस्टम को जानने के लिए पढ़ रहा था एक आर्टिकल डिफेंस डाइजेस्ट अमेरिका से, आर्टिफिशियल इंटेलिजेंस विल नॉट बी यूजफुल फॉर कोविड बट फॉर द नेक्स्ट पैंडेमिक। Gentlemen, this gives the symptom of application of our tomorrow's computing systems. Second idea it gets from here that evil forces will find it more devastating and they will use it as a weapon. They have seen the havoc, they have seen the ruining of economy, country. So I feel the next generation has to look after these challenges. अभी मैं 2 महीने पहले I was talking to one of my friend Major S.K. Dwivedi. The news was that Pakistan is devastated heavily by locusts. टिड्डियों के दल ने पाकिस्तान पर हमला किया है and Pakistan is asking the support of China. मेजर एसके द्विवेदी ने सलाह दिया कि हम लोग एक हेलीकॉप्टर में टिड्डियों को भर करके अगर किसी देश में ले जाएं और लो फ्लाइंग करके उसको वहां छोड़ दें, then the devastation will bring famine in that country. That was the way to interpret as a soldier, as an army man. उन्होंने application पाई है. But what I feel is that now human society will certainly move into this knowledge. और अभी मैं 1 हफ्ते पहले न्यूज पढ़ रहा था कि इंडिया suffers biggest locust attack in last 25 years. 25 वर्षों में सबसे बड़ी टिड्डियों का अटैक। हम लोग जानते हैं स्वार्म इंटेलिजेंस 1989 में आया। इन 1989 प्रोफेसर गिरार्डो बेनी एंड जिंग वांग from University of California, they introduced SI, swarm intelligence, जिसमें कलेक्टिव चींटियों का हो, एंड्स या हर्ड सीप्स के हर्ड्स का हो, उनके इंटेलिजेंस पर उन्होंने काम किया था। एंड टुडे आई कैन फील दैट लेजर बीम्स कैन मेक थर्मल करेंट्स and these locust fleet can be navigated to any country using the technology. These are 3 examples जो हमने दिए। हेल्थ मैप का पैंडेमिक प्रिडिक्शन, आर्टिफिशियल इंटेलिजेंस will be used for next pandemic, swarm intelligence is now matured enough to be used in future study of biosciences and community health care. These will find applications in next generation of computing system. That is why I decided with head of department MCA, Dr. Brajesh Bharadwaj, why not to go for international seminar and share the knowledge, listen the wise people across the globe to understand more and more about next generation of computing. I'm very much delighted with the presence of all the delegates, Honorable Vice Chancellor, sir, Honorable Pro Vice Chancellor, sir, Honorable Director IQAC, Honorable Professor R.N. Rai, sir, Honorable Professor, I have Talal Yusuf, sir, from Australia. Sir is Pro Vice Chancellor and he will be with us only for a few minutes. So, I will be inviting him to present his talk and guide us. Over to you, Professor Talal, sir. Professor Talal, sir, मुझे सुन पा रहे हैं? Professor Talal, sir, are you able to listen me?
Yeah. Can you hear me now?
Oh, yes, sir. You are audible as well as visible. Over to you, sir.
All right. Thank you very much. And thank you very much for the very last minute invitation. And I would like to acknowledge colleagues, Vice Chancellor, Pro Vice Chancellor, Dean Directors, and other colleagues and students from the institution. And I'm very sorry I can't spend more time with you. I have another commitment, as you know, today's Sunday and it's an Australian weekend. So look, I would like to first to introduce myself. I'm not a computer scientist. I am professor in renewable energy and mechanical engineering and Pro Vice Chancellor or ex-Pro Vice Chancellor of Federation University Australia. And recently I moved to take the lead at Aviation Australia. So I'm very keen to share a little bit about Aviation Australia and how COVID-19 affected our business and how the technology that you are now discussing in this beautiful gathering going to also benefit the technology, especially the drone technology, which I feel it is very important bit of business for aviation. I believe very much into online delivery, and I came from University of Southern Queensland. I spent about 20 years of my academic life, and we used to have about 23,000 online students, and we've gone through a lot of hassle and bustle with the quality assurance agencies and also the international bodies to recognize the delivery in engineering and science, which, as you know, it's a bit challenging. We have University of Southern Queensland have 40 years, and I'm still part of University of Southern Queensland as an adjunct professor. So we have 40 years in delivering online, and we started when we used to print out the study material and send them by post office. They return back to us, and we sign them and we mark them and send them back to the student. And we develop further into PDF, and then we develop our system. And now we have all the technology where we have, the University of Southern Queensland have, I think about 25,000 students across students in South Africa, some of them in India, not many, but we have many in Malaysia and Middle East, as well as domestic students. So online technology got a little bit of challenges, and I wish to highlight maybe a couple or few of them with you, and you can take them for discussion. And I'm very happy for the organizer to pass on my contact to colleagues and happy to chat and talk with all of them after this webinar. So the challenges we faced, number one is the quality assurance framework. So the quality assurance, and in last 2 years we've gathered a group of leaders in online delivery in Bali in Indonesia, and we developed a fantastic quality assurance framework with the support of TEXA. TEXA is the quality is the tertiary education quality assurance framework in Australia. Can you hear me, by the way? All good?
Yes, sir.
Yes,
You
sir.
are audible, very well audible.
Excellent, very good. So quality assurance is one issue. We resolve it, and just we want to give you example. We want to make sure, for example, John, who is sitting in Malaysia, is the one who's sitting for the exam, and it is a challenges, especially when it comes to science and technology. So what we've done, we organized 2 weeks residential school, and students will come to Australia and they do the practical courses with us. And this way we had to revisit or revise the curriculum. So you can see over 40 years, we've learned a lot in online delivery. And this is the time for, for many universities to start. But I personally have massive experience starting from teaching courses till organizing curriculum till, leading the university. Another matter is the tuition fees. As you know, some student and sponsor also, they believe that, okay, tuition fees should be less when it comes to online delivery. That's not true, actually. The online delivery costs more money, as you know, and we have to use all the technology and so on and so forth. And especially when it comes to international students, because my previous job as a Pro-Vice Chancellor International, I look after international. We have in Federation University, we have about 10,000 international students, by the way, about 5,000 of them from India. So we've got many students from India. So we had to cope with the change of COVID-19, and changing to COVID-19 allow us now, or force us actually, to use the online technology to deliver courses. And again, there's no more excuses. Example, University of Southern Queensland is one of the recognized university in United Arab Emirates, for example, and I had to go there and explain to them. This happened 10, 20 years ago, but now it become a must for all of us. The third point when it comes to online technology is the recognition by the government, which I'm very sure colleagues, the Vice Chancellor and the Pro-Vice Chancellors and the senior, they, we struggle, to get the online delivery recognized by government. We have many students from Saudi, for example, from Brazil, from India, even India itself, they not believe that much in online delivery. So my job was, to go and travel and meet with the ministries and demonstrate to them that this online technology is as good as face-to-face and as efficient. And engineers, you understand what I'm talking about. And actually, what they call the Washington Accord, Dublin Accord, and Sydney Accord recognize the USCQ delivery online. Summary, what I wanted to say, delivering online courses in science and technology is a challenging, but it become real. And thank you for computer scientists who help us to facilitate this. The second point which I wanted to share with you, I hear the Vice Chancellor spoken about renewable energy, which is, again, that's my research field and technology. So yes, I agree. We should collaborate together. We should work together because, with energy, computer science, water, and all these things, all are important elements in the coming century. So the last bit, which I wanted to share with you colleagues, I've recently taken the lead in Aviation Australia. So I'm now leading the Aviation Australian business. And Aviation Australia, actually, it's an academy. We have about 10,000 students. We've got about 4,000 students in Saudi, a few hundred in Malaysia. We have in Sri Lanka. And we're very open, and I personally open, to partner with you colleagues in in the technology, and I'm very sure you're doing engineering, and with all these artificial neural network and virtual reality, we will be able to deliver a lot of online courses, or using the technology to help delivering aviation courses. We in Aviation Australia, we're delivering aircraft maintenance, aircraft engineering maintenance, and also we doing pilot, and now recently we moved to drone technology, and just now you mentioned car without a driver. So this is quite close to what we are thinking now. And we start developing actually technology in drone, where we have aircraft with no pilot. And again, this definitely comes with some complication when it comes to control, the technology of GPS and geographical information system, and logistic as well, and so on and so forth. So I just wanted to open this door before I leave, for you colleagues to think, and hopefully we will shake hand one day together and we work in that technology. For your information, I very much believe in TNE, which is transnational education. So we're happy to explore opportunity. Again, I would like to thank all of you, especially the organizer. Rajiv, you've done a fantastic job. You got me in the very last minute, and he really was so keen to get me into this. So I'm very glad to be with you, but unfortunately 5 o'clock Australian time, I have to be in another function. Look, I'm happy to take any comment or any question for the coming 10-15 minutes if needed. Thank you.
Thank you so much, sir.
Thank you, Professor Talal Yusuf, sir, for enlightening us on online education and aviation industry. Drone technology education is new form which is going to come. Very good thought-provoking ideas you have given. You said you are from aviation industry, so this next generation computing, sir, swarm intelligence, the concept was given by Professor Girard, and he is from electrical engineering background. So, sir, your valuable guidance having on such a highest order of education is really helpful to us. Thank you so much, sir. Now, available with us, I request Professor Ashok Shukla, sir, Director IQAC, to bless us.
Thank you, Ramapati ji.
Welcome, sir.
Am I audible?
Yes, sir.
Fine. It's a wonderful topic. Let me congratulate the organizers, you, Brijesh, Rajiv, Paritosh, Ramesh, and all, for choosing such a wonderful topic. We had been discussing for long about so many dimensions and the impact of COVID-19. But this one, which was within your grace, you raised it, but you came with a bang and you made it international. You are to be complimented. So like Yusuf, I am also not a man of computers, but yes, I am very closely associated with COVID-19 and the developments all around the world about it. And as a student of business management, I'd say that since we are here to deliver and discuss the future computing amidst COVID-19, your field, computing particularly, in marketing parlance, that is marketing management, the student of which I am, it has bracketed you in a philosophy which is known as the product concept of marketing. Now, this is one area, the technology in general and computing in particular, where the rapid changes are the demand of the hour. You don't have to look for customers in this zone. Customers automatically, they look upon you, rather they impose a demand upon you to move ahead in the branch. say the rapid developments which have taken place in during the years are quite visible. Even Ramapati ji introduced computing right from first generation to fifth. See the small span of time within which we are at 5G stage. Very recently, say 2 days back, I was going through newspapers and televisions, and I found that Japan is developing a technology that by year 2050, they said, or 30, I don't exactly remember, will be having a kind of a clone of human beings which can move here and there. That is Ashok Shukla being stationary in Ayodhya or Varanasi, and the same Ashok Shukla will be there in London, will be there in New York, will be there in Wuhan, if need be. The kind of computing is going that way. What the development is that we have to look upon, that basically what I feel is that I am not a technical expert and therefore I cannot go into it. But as a student of marketing and of management, I can say that it has given us an opportunity, this COVID-19, that we had been a major force to reckon with in information technology. But this opportunity which has come to our lap is that how we can seclude China, how we can segregate China side by side, advancing ourselves in this world. I know there are a lot of speakers, a lot of things are to be spoken. I'll be regularly listening to all of you and enriching myself. Thank you very much for providing this opportunity. I once again compliment you all and congratulate you all for having such a nice theme and topic. Thank you very much.
Thank you so much, sir, for blessing us and giving a hint that next generation computing system will also be linked to the marketing. Of course, using data mining, we are moving ahead, but certainly new scopes are there. Thank you so much, sir. Now I request Honorable Pro Vice Chancellor, sir, to bless us to make inaugural address. Are you listening? Are you able to listen,
yes,
sir?
Yes, of course.
Over to you, Honorable sir.
Thank you, Ramapati ji, and thanks to the organizing team for giving me the opportunity to interact with the leaders of computer sciences and the elite researchers who are involved with the recent technologies of computer sciences. But before saying anything about this, about the theme of the international conference, I just would like to express recently in his lecture, Professor Ashok Shukla has told that has quoted an example that he might be, his clone might be in Wuhan and in London simultaneously with the help of recent computer technologies. So I just want to reply, I just want to add that we don't want Professor Ashok Shukla in any form, at least in Wuhan. So far as the field of computer technology is concerned, this is one of the recently growing technology, and all of us can witness the rapid changes almost every day in this field of computer technology. If you have started with some, architecture today, after 1 month, you will find that this architecture has been almost obsolete, and a new kind of architecture is available in market with some more advanced features. As Professor Ramapati has told, that we are moving in the 5th generation of computer sciences, computer technology. If we go back, if we go 30 or 40 years back, we can even not imagine about the laptop and iPad and the smart mobile phones. But these are the realities nowadays. And similarly, the future of the computer technology will be definitely come up with a virtual screen in next 10 or 15 years. And even you can do everything which nowadays you are doing on your computer screen or with touch screen, on the air screen and in the space. So this kind of technology, I think, will be come up definitely in next 10 to 15 years, and this is the future. But so far as the current researches in this field is concerned, I think the researches in the direction of optical computers, quantum computers, and especially in the field of biology and computer interface of biology and computer sciences. This will emerge as the future technology in the computer field. The biotransistors will definitely emerge as game changer in recent days, because I think this computer technology has got space in almost every sector of the society, whether it is the medical field, or it is the aviation, or it is the mechanical or electrical, every field. Without involvement of computer technology, we cannot think any less about this. So I think there are many researches pipelined, and the outcomes with those researches in next few years will be change the complete scenario of computer technology field. I will not spend much more time, because so many speakers are already waiting in the waiting room for their turn. So at last, I would like to welcome every speaker, every academician who is connected on this e-platform and participating in this international conference on the recent technologies, future technologies in computer sciences. I warmly welcome all of you on behalf of my university, Dr. Ram Manohar Lohia Awadh University, my Vice Chancellor, Professor Manoj Dikshit ji, and the Institute of Engineering and Technology.
Thank you so much, sir. Blessing us, motivating us. Thank you so much, sir. Now we are having our Honorable Vice Chancellor, sir, for guiding and blessing. Sir, are you able to listen me, sir?
I can very much listen here too. I don't know whether my video is working or not.
Video is not working, sir. Video is not working, but you are audible.
But my voice is there, right?
Yes, sir.
Thank you so much. I think this is a wonderful opportunity for most of you, the teachers and faculty members of Awadh University, as also the participants who are taking part from far and wide. I can see some of the faces there. And we are discussing about the future computing and technology, and there are two kinds of responses that I can understand. One is that a typical euphoric response. I could say that the technology is going to change us all, and technology, is doing wonders, and probably it will change the way we are. That is the future. A second, of course, is the skeptical responses. Skepticism is always there. So who always believe that it's going to change for the worse. So for the change for good and change for worse, so the two extreme scenario in between which we are working right now, we are thinking right now. I don't know how this is going to be, but I must say this, that in every age, the technology has been as advanced as this is. Only thing is that the age itself was not as advanced as today's age. And therefore, every technology that is brought forward does change or does hit upon your value systems. And during a period of time, they gradually are adopted and adapted, and they become our values. I heard Professor Ashok Shukla, making his point, and the line is very clear. For example, there is a skepticism that if online things are going to take over in future, what will happen? So the typical teacher-taught relationship, which shaped the country world so far. Secondly, what will happen to the classrooms if the countrywide? What is going to happen? So between these two extremes is the reality. Unfortunate realities are always there. Good realities are always there. We are working on the impact of computer technology on our understanding. And side by side, there are people working on the impact of this same technology on our health. The impact of the same technology on our family systems, the social systems, the economic systems. So all impacts are not going to be the same or similar in nature. And therefore, I always request my great technology friends that technology has to have a human face. Please do not develop Wuhans. They will destroy humanity. That is also some kind of a wonderful, discovery or exploration. But for what? Well, definitely not for good for the nation, good for humanity. So the technology and the family systems and the value systems and the socioeconomic paradigms of the nations must be protected during the same phase or period of adapting to a new technology. With these, I give my best wishes, I submit my best wishes for the success of this webinar, and I hope that we will definitely come out with some solutions for the country like India, and a similar indigenous solution of technology for the people of India is needed, something on which I exhort my friends in Institute of Engineering and Technology and your participants to develop something which is very indigenous and very Indian in nature and character, and as well as modern in the ICT terms. Thank you very much, and my best wishes to all of you.
Thank you, Honorable Sir, for giving us a caution for all technologists that technology and value system is to be looked after. Teacher and taught relation is to be looked after. Technology has to have human face to avoid further Wuhan. Thank you so much, sir. You always have been my guiding force. And for IIT, thank you so much, sir, for sparing time. सर को अभी जाना है, ये हम लोगों को समय बहुत कम दे पाए हैं, but still we are blessed to have his words. Now we start with Dr. Brajesh Bharadwaj. आप मुझे सुन पा रहे हैं? डॉक्टर ब्रजेश भारद्वाज नहीं है? फॉर नेक्स्ट हैं तो आ नहीं पा रहे क्या? नेक्स्ट टेक्निकल सेशन में कौन आएगा?
Sir, Dr. Anshul Verma, sir. He is from Computer Science and Engineering Department from BHU Varanasi, sir.
हाँ, Dr. Anshul Verma from Computer Science and Engineering Department, BHU. Sir, सुन पा रहे हैं? Sir. Are you able to? Anshul Verma, sir.
Yes, sir. He is with us.
अच्छा, अभी वो सुन नहीं पा रहे हैं.
अंकुल सर, आवाज आ रही है आपको? जी हाँ, आ रही होगी. अंकुल सर, जी हाँ सर, अनम्यूट करिए सर.
Yes. Yeah. I was doing unmute, so it was taking some seconds. Okay, so now I am audible.
Yes, sir.
Okay, thank you so much to invite me in this wonderful conference, and very good afternoon to Honorable Vice Chancellor, Pro Vice Chancellor, and all the experts and faculty members. And so, shall I start my technical session?
Sure, sir.
Yes, sir.
Welcome, sir. Welcome.
Thank you so much. Thank you. Okay. So I would like to share some PPTs. So shall I share my screen?
Yes, sir. Yes, sir. Share.
Okay. Okay. Thank you so much. Thank you. Yeah. Okay. So shall we start?
Yes, sir. Yes, sir.
Okay. 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 Thank you so much. Okay. So
Sir,
in
now
this.
your screen is visible, sir.
Okay. 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 So in this session, we will discuss about opportunistic networks, applications, and research trends. So okay, so we will start. So in this session, we will discuss what is opportunistic network and how it is different from traditional mobile ad hoc network and delete-only networks. Then we will discuss about applications of ad hoc opportunistic networks. Then we will discuss about few current research trends in this area. Okay, so now we will discuss what is opportunistic network. So opportunistic network is an extension of mobile ad hoc network, or we can say this is an evolution of mobile ad hoc network. So before discussing about opportunistic network, we will see what is mobile ad hoc network and how opportunistic network is different from mobile ad hoc network. So as we know, mobile ad hoc network is an infrastructure-less autonomous made of mobile nodes network. So opportunistic network is evolution of mobile ad hoc network. So opportunistic network shares many properties of mobile ad hoc network, but in routing aspect, it is totally different from mobile ad hoc network. So first we will see what is mobile ad hoc network. So as we know in computer science, computer networks can be classified into two categories. One is infrastructure full network, one is wired network, and another one is wireless network. And wireless network can be further classified into two categories. One is infrastructure full network and another one is infrastructure less network. And in infrastructure full network, the examples are cellular mobile network and Wi-Fi network. All we have used all these networks so we can understand. So these are called infrastructure full network. Why? Because the network manages location of each device. So if one device want to communicate to another device, so network can trace the route from source to destination. But in ad hoc wireless network, that is infrastructure less network. In this network does not rely on the network does not rely on the existing infrastructure. And so if a node want to transmit some information to another node, then that node first need to discover a route. Then that node can transmit information to the destination. So this हेलो हेलो
हाँ सुजन, आप सुन रहे हैं? हेलो
Yes. Yes, sir. Hello, Anshul sir. Hello, Anshul sir. Are you there, sir? Yes, sir. Now you are visible, sir.
Yeah. Okay,
Yes,
okay.
sir.
I think due to some technical fault, I was disconnected.
Yes, sir. Sir, I
Okay,
think you
okay.
are
So
on low bandwidth, sir.
yeah. Okay, so I am again sharing my screen. Okay.
Yes, sir. Please, sir.
Okay.
Now your screen is visible, sir.
Okay, man. Thank you, man. Okay, so I was discussing mobile ad hoc network. So in mobile ad hoc network, if a node want to transmit a message, so first of all, it needs to create it needs to discover a path. Then it can transmit a message. But because the nodes are mobile, so the intermediate node can go beyond the communication range. So the path will break and the whole transmission will be lost. So that this is the drawback of mobile ad hoc network, and that drawback is overcome by the opportunistic network. It means even the nodes are highly movable, still in opportunistic network we can transmit information. Okay, so the disconnections of node, mobility of users, network partitions, and link instability properties are treated as a drawback in mobile ad hoc network, whereas in opportunistic networks, all those properties are treated as advantage. Okay, so this is in this figure you can see like this is the infrastructure full wireless network, for example Wi-Fi network or cellular mobile network, and this one is example of wireless ad hoc network. Okay, so now we will discuss about opportunistic network. In mobile ad hoc network, we need end-to-end connection for data transmission. Means there should be a path from source to destination at the time of transmission. But in opportunistic network, what we do, we will transmit a message without discovering path. And the approach will be such that we can transfer a message closer to the destination as much as possible. So this is the main concept of opportunistic networks, and that's why this approach is called store, carry, and forward fashion. Means if there is not end-to-end connection, means destination and source are not connected to the same network at the same time, still we can transmit information. You can realize like that in email. If you want to transmit an email to another person, so that person should not be online at that time, still you can transmit email. But if you want to call someone by cellular mobile or landline phone, that person should be connected to the that cellular network, then only you can call him. Okay, so similarly in opportunistic network we can transmit a message by exploiting connectivity to your neighbors. So there is no need to end-to-end connections. We can forward message in store, carry, and forward fashion. For example, in this diagram, you can see the both end there is source and user. So this person suppose want to transmit a message to this person. So there may be at any time there is not a complete path from source to destination, but one person that was traveling in a bus is going to the direction to the destination. So that person can hand over that message to that person, that is source can hand over that message to the person who is traveling in bus, and that bus will go in the city uh, in which the destination are, and from the bus this message will be delivered to other person that is more close, much closer than the current person. So in this way, by following opportunity we can transmit a message from source to destination. So one thing is this is called store, carry and forward. A person can store a message when that person does not have opportunity to forward it further to destination, and that person can carry that message towards the destination, and when he will get opportunity to deliver the message to destination or some other intermediate node that has better opportunity to meet with destination, then that message will be forwarded to that intermediate nodes. Okay, so this is the concept of opportunistic network. So what are the advantage of opportunistic network? The main advantage of opportunistic network is you can provide connectivity to the region in which you do not have existing infrastructure like a cellular network or internet kind of network. You do not have, still you can provide internet connectivity. So we will see many application of the opportunistic network in real life. And a similar kind of network is delay tolerant network. It is much similar to opportunistic network. The difference between opportunistic network and delay tolerant network is that delay tolerant network made of clusters of many ad hoc networks or internet based network. Suppose this is a scenario of a war. There are some soldiers, those are in a battlefield and they are connected through any ad hoc infrastructure or internet like infrastructure, but their information cannot be transmitted to the base station. Why? Because they are so far from the base station. They do not have there is not due to geographical area, there is not internet connectivity, so they cannot transmit information to their base station. So but there is, if they are installing delay tolerant network, so here we can see there is one ship that is base station and here is one helicopter. So when periodically that helicopter will fly over, then due to this helicopter there will be one communication, like this device can communicate to helicopter and further helicopter can deliver message to that ship. So this is called delay tolerant network. So what is the difference between delay tolerant network and opportunistic network? In delay tolerant network, there are some clusters of existing network and connectivity between these clusters are totally opportunistic. And if we will replace this cluster of networks with a individual node, then it will become opportunistic network. And in delay tolerant network, the connectivity and disconnection point are pre-node. For example, like that soldier cannot connect to that helicopter. So there is one entry or exit point, this point. This point can only connect to the helicopter. But in opportunistic network, this whole cluster can be replaced by a single node. Means each individual node can communicate with each other opportunistically. Okay, so this is the basic difference between delay tolerant network, mobile ad hoc network, and opportunistic network. Now we will see some real life examples of opportunistic networks where this concept has been used. So despite of the research is new in that area, there are many concrete applications. For example, Darknet project, ZebraNet project, and Haggle project. So first we will discuss Darknet project. Darknet means this name is generated by the Hindi word Dakia. So so this concept is based on the postman, or we can say Dakia. This project is used to provide internet connectivity or digital connectivity to villagers. So where there is no cellular mobile network or there is no internet kind of network, and or they are not able to pay the fees for those kind of network. So government can provide digital connectivity to those areas. So this is called asynchronous digital connectivity. So by this diagram we can see. So according to Darknet, what is the main concept? Suppose there are some rural area and there is one city. So in that city, what we will do, we will install some trans receiver antenna, and that hub or that office is connected to the internet, because this is city or town. Okay, so what we will do, we will install some trans receiver devices on roadways buses, public transport vehicles. We will install some devices. Okay, so when that bus will go according to their schedule and visit some rural areas, then these rural areas, all the devices of those villages, when that bus will pass that location, the people will upload automatically without intervention of anyone. Those devices will upload data to the bus, and if there are some data on bus, those are related to those devices, those will be downloaded or will be delivered to those devices. If people do not have such type of devices, then government can install some kiosk booth, so that villagers can register their whatever service they need on these kiosk booth. And when these buses will pass through this village, then kiosk booth will upload information to that bus, and that bus will deliver data, if that bus have, to these kiosk booth. So what is the concept here? So by using public transport vehicle and by using information and communication technology, we are providing asynchronous connectivity to the villagers. And this concept has been used for many applications in South India. For example, there was a project that's name was Bhumi project, Bhumi e-governance. So according to this, if someone wants land record, if someone want to purchase some land and he needs a land record of that land, then currently he need to go district office and he need to register some complaint, and then next day he will receive some information. But according to this Bhumi e-governance, the person can register that land record complaint or land record query information on the kiosk booth placed in the village, and similarly that information will be uploaded on the public transportation buses, and that information will be delivered to district office, and next day or in next trip the result will be again uploaded on these public buses. And when this bus will pass through the village, then that information or result will be uploaded to the kiosk booth. So in this way, without going anywhere, villagers can access internet connectivity or can access internet facility in their village without internet. And same kind of project was implemented in a its name is Drishti project. So this project was developed for providing not only land records, all kind of government certificates like income certificates and caste certificates. So by same concept. And in Cambodia, same concept was used to develop one project that's name was Internet Motorman. So that concept they used this concept for providing internet connectivity in the forest area to government schools. So, but in those villages or in those forest areas, they do not have bus facility. So what they do, what they did, they implemented these trans receiver devices. Those we have implemented on buses. They implemented those devices on bicycle or motorcycles and bull carts. So by same concept, they were providing internet connectivity to their primary schools, government schools children. Okay, so this is the darknet concept. And the next example or case study is ZebraNet. So in Kenya, by Mapala Research Group, they implemented that ZebraNet for wildlife tracking and monitoring purpose. So they want to study on zebra. So how they are behaving, how they are moving, why they are migrating from one location to another location. So what they did, they attached one electronic collar that has some GPS devices, flash memory, and wireless transceiver, and some programmable CPU. Okay, so they attached one collar to each zebra, and because that area was so vast and there was no internet connectivity or cellular network, so there was no mean to collect information from those zebras. So they used opportunistic network. So because there was too much population of zebras, so there were the area was dense by these zebras. So by hopping that information from one collar to another collar, that information they were collecting on base station for the further study. So like in this figure you can see, so these are researchers, they are attaching one collar to zebra, and this is a zebra that has that collar. So and that collar has GPS to locate their locations, and some cameras to see what they are doing, and some CPU and transceiver to transmit information. So in this way, they have implemented opportunistic network for studying the behavior of zebras in wildlife. And similar kind of network have been implemented for shark network and underwater network. And another example is Haggle project. This is a software architecture to provide this kind of facilities. So because the working of opportunistic network is totally different from internet or ad hoc network. So we cannot rely on existing TCP/IP protocol or ISO protocol suites. So for that, researchers have developed one architecture that has only physical layer, data link layer, and application layer. And message transmission and session creation, all responsibility was of application layer. So it does not have network layer, session layer, transport layer, presentation layer, does not have, because this network has very limited functionality, and TCP/IP protocol has to do lots of things. That's why that is very complex. So here in this network, we do not need such type of protocol stacks. So that's why researchers have developed Haggle project. It was a software architecture. On the basis of that software architecture, there were many applications like PhotoShare that to share between photo. It is similar to ShareIt. If many students have been used ShareIt application, it is similar to ShareIt, but in ShareIt ShareIt is a centralized approach. Means you need internet connection. First, your content will be uploaded on internet server. Then from that server, that content will be transmitted to others. But in PhotoShare, you do not need internet connectivity. Using Bluetooth, people can share their photos. And similarly, MobiClick. This is similar to Facebook. So like in Facebook, if you have internet connection, then only you can use Facebook. But in MobiClick, you can utilize Facebook kind of services without internet. Why? Because we all are using mobile phones. So if you want to transmit a message to another person, so there will be some mechanism so that by hopping one to another person, we can transmit that message to the destination. Similarly, there was one application, opportunistic Twitter. So this was same as Twitter, but no need of internet connectivity. And another one is mail proxy application. So that application is for transmitting emails without internet connectivity. Okay, so one main drawback of can use opportunistic only and only for non-real-time communication. Okay, suppose if we are suppose we are doing that video conference, we cannot use opportunistic network for that video conferencing. Why? Because we need guarantee of service, quality of service for this application. But opportunistic network, we can transmit data by guarantee, but how long it will take time, how much time it will take, we cannot ensure. So this is a further research direction, how we can provide quality of service and how we can ensure communication time in opportunistic network. Okay, so there are lots of applications and industrial industrial applications and many case studies on the basis of opportunistic networks. And so that's why, because that has many potential applications right now. Why? Because now we all are using mobile devices, and mobile devices, by using mobile devices or by exploiting handheld mobile devices, we can develop lots of applications. Those are very essential for our daily life. Okay, so that's why the all aspects of opportunistic network should be investigated further for make that area very fruitful. And few main research directions are developing routing protocols for opportunistic network, because opportunistic network routing concept is totally different from mobile ad hoc network and internet network. So that's why developing routing protocols is a main research area. And in opportunistic network, routing protocols are categorized into three categories: context oblivious, partially context aware, and fully context aware. Context information means for deciding, like I have shown you one opportunistic network example, then in which we were using buses and many people for transmitting information from source to destination. So how there are lots of people, then how we will decide which people or which mobile device will be a good forwarder? So we need to decide this, because there are thousands of devices. How we will select one device which will be better forwarder? So we can decide this on the basis of past experience of that devices. So that is called what? Context information. There may be lots of information that we can process and predict which device will be the better forwarder for a message. So next research direction is modeling social relationship of users, so that we can use those models or mobility pattern in routing protocols. And one main issue is, see, why opportunistic network we are not using broadly? Because we cannot ensure connectivity worldwide by using opportunistic network, because they to connect it to different continental or to different countries, there may be much gap between. Okay, so if we can combine infrastructure full network and infrastructure less network together, so that we can fully utilize the concept of opportunistic network. So resolving all the issues in interoperability of infrastructure full and infrastructure less networks may be a good research direction. Another research direction is, see, in opportunistic network, we are delivering our data to other mobile node that may be not a reliable node, and that may be an intruder that can access your data, and instead of forwarding that data, he can misuse your data. But the concept of opportunistic network is such that you have to transmit your data to another node to make it possible to forward to your destination. Okay, so the privacy and security is main concern in opportunistic mechanism, so that we can forward our data to the other mobile devices or intermediate node, but they cannot misuse our information. So this is another direction for research. And one more research direction is developing many kinds of application on the basis of opportunistic networking paradigm, and providing adequate quality of service is also a main research area. And energy consumption is another main research area. Why energy consumption? Because we are using mobile devices. If we are developing such kind of routing protocol or such kind of application, those needs a good amount of computation, then the battery power of the mobile devices will be very less. So that's why we reduction of energy consumption is another research area. And these are my few publications on the opportunistic network applications and routing protocol. So you can refer them for further information. Okay, thank you so much for your kind support. Okay, so I am stopping my screen.
Anshul Verma sir,
Okay.
for sparing time for us and sharing trending areas like opportunistic network and delayed network. These areas will really be benefited for our students and our researchers. Thank you so much, sir, for sparing time for us. Thank you so
Thank
much.
you so much. Thank you so much, ma'am. Thank you
And
so
now
much.
our next eminent speaker with us from School of Computer System Sciences, Dr. Karan Singh from JNU. Sir, are you able to hear me, sir? Dr. Karan Singh, sir. Dr. Karan Singh, sir.
हेलो।
हाँ जी सर।
हाँ, ये मेरा म्यूट था ना माइक।
Okay, okay, sir.
हाँ,
Right now you are audible, sir.
Okay, okay. Just 1 minute, okay?
Yes, yes, sure, sir.
Yes, now I am ready. Yes. Hello.
Yes, you are visible, sir.
Okay. So can I share my screen?
Yeah, definitely, sir.
Most welcome, sir.
Okay, thank you.
Now screen is visible, sir.
Okay. So now I am going to full screen. Yes. Now it is visible.
Yes, sir.
Yes, sir.
Yeah. Thank you very much to organizing committee, especially Rajiv, Manisha, and VC sir, director sir, HOD. Okay, who provided me this opportunity.
Yes, sir.
So I will take this session on age of communication and smart computing. Okay. So my session is a simple general. Okay, not more technical. But I try to touch maximum thing which is related to communication and smart computing. Okay.
Yeah, okay, sir.
Now, before starting this session, we will salute to these COVID-19 warriors who are going to save us. Okay. So the motivation behind my talk is this Jita age. What we are doing, we are going to generate the lot of data. And what is the impact of that data? So Jita is the one term from our byte system. And like this, we know about the bit, byte, okay, kilobyte. So there is a one place of the Jita. Okay. Suppose we are going to generate some data. So it is going to store somewhere. And it is going to create a huge volume for same. So that is a called Jita age. So Jita means you can see here what is the meaning of the Jita. It will become after exeta. Okay. This one. Now, second motivation is what are the different type of the device we are going to use to generate these data. Okay. For example, there is a wearable device, there is a some smart home device, there is a smart TV. Okay, smart mobile is the number one, and there is a PC, computer, laptop. So these are the different type of the device which are going to use to generate the data. So this is also part of the computing. Now, what is the growth of the computing or smart computing? What was the before today? Okay, if we talk about the 90 or 96, so there was the only manufacturing computing. Okay, we are going to create something. Okay, after 90, 60, there is a age of personal computing. Okay, we are going to distribute some small information from one place to another place via personal computer. Then in the age of the 90, we have tried to send the information via network through age of the information. So you just see here that is a network computing. Now we are the age of the uh, customer. Means many things are going to created and they are reaching up to customer, so that is with the help of the smart computing. Means suppose you have a smart kind of the device mobile, you just give the order and you receive the regarding order. Now these are the main part of our smart computing, or you just say the next generation computing. If we talk about the computing, so there are the many things which are going to use in current scenario, and it will be the part of the future one. So there are the many things in which there are the multicast is one, multicast communication. For example, we are going to send some data from one place to another place. So we need some kind of the technology. So one technology is the multicast. So we will discuss later on. Another one is the WSN, yani we means wireless sensor network. So some sensing technology is going to use inside of your smartphone, as well as in many applications. Then one is the grid computing, which is going to use for management of the kind of the electric system. And there is a RFID one technology by which we are going to scan something, and we are going to gather the information with help of the RFID. So there is a some one kind of the tag which is attached with one system, and one device which read that tag. So many things is based on this technology also. Okay. Now another one is the CPS. CPS means there is a cyber physical system. Okay, which is going to attach with this kind of the grid system, and it is providing some information or kind of the support to grid system or other kind of the systems. Now, most famous term is the Internet of Thing and cloud. Internet of Thing is the part of the IOV, Internet of the Everything. Means there are the many devices which are going to connect with Internet. So Internet of Thing is one of the part from IOV. Now, how your data is going to store? It is, I think we will store the data on server. So you just say the extension of the server is a kind of the cloud. So these are the multiple kind of the technology which is going to use in current scenario and future one. But what is the requirement of these computing or these technology? You just see here, they are the first requirement is the efficiency. It means your system or your computer, your computing device should be very efficient. So it will be achieved by supercomputing kind of thing, or in future a quantum computing. It is going to use to make it the efficient. So second part is the intelligence. In case of the intelligence, there are the many algorithm exist related to intelligence, or we provide the AI, ML, and deep learning part to make the system as a intelligent. The third part is the suppose we are going to communicate to each other, then we need a kind of the security. So there are the many parameter we will discuss later on, what are the different part of the security. Okay, which is going to use inside of these computing. Now the base of these computing, or we say the suppose we want to send the data from one place to another place, so there is a base, and that base is the network, or you say the computer network. So if we discuss about the one or two slide about the computer network, what is the computer network? Computer network is a set of the device connected by autonomous system. Okay, so there are the many example already, you know what are the different example of the computer network we are going to use in office, airport, hospital. There are the many application. I am not going to discuss, and there are the some component I will discuss in the next slide. Now, what is the main objective of a computer network or any kind of the communication system? So there are the two main objective. First objective is to minimize the delay. Suppose we are going to send some data from one place to another place. So your delay should be minimum. So this is the one objective. We need to analysis that part by some tools, some methods, and we try to minimize the delay in these existing system. Second part is the minimize the throughput. So how we minimize the throughput? There are the many algorithms. We will use some method to minimize the throughput. Now this is the one pictorial form of your computer network. What is exactly computer network? So in this part, there is a mainly we start from the topology. So suppose we have a system kind of the computer network, then there is a physical representation, we call it topology. And there are the many classification like tree, ring, star, bus. Okay, means we connect all device with some physical system and we call it topology. So we use according to our requirement one topology. Then how we transmit the data? So there are the two methods. One is the wired and second one is the wireless. So by these method we use the we transmit the data from one place to another place. Now we can divide these system into different parts. We just say the LAN, HAN, CAN, MAN, and WAN. And this depend upon the distance from one node to another node. So there is just some distance. According to that, we categorize the different type of the network. The main and most important part of the computer network is model. So there are the two type of the model. One is the OSI model and second one is the TCP/IP model. In OSI model, it is a reference model. Generally, we use the TCP/IP model. In TCP/IP model, there are the 5 layers. We called it application layer, transport layer, network layer, and data link layer. There are the 2 part MAC and NLC. Now, last one is the physical layers. We read these layer system according to order. Okay, suppose we want to send a data from one source to another one, that is a destination. So we follow this layer system. First data is going to generate on the application layer, then it will reach to transport, then network, then data, and last on physical. Okay. Now in a TCP/IP model, there are the different type of the protocols. Protocol is going to use for a set of the rules. For example, there is a TCP protocol. It means there are the some sets of the rule which is going to follow on transport layer. Suppose we send the data, so it will reach to transport layer. Then it will, suppose it is going to follow TCP protocol. So there are the some rules. By that rule, it is going to scan. If we compare the TCP and UDP, TCP we say it is a reliable protocol and UDP is very faster protocol. So according to our requirement, we use the protocol. Okay. And there is a network, there is a IP protocol is most important protocol on network layer. Okay. On application or physical, these are the merge on application layer in case of the TCP/IP model, and there are the multiple protocol exists on application layer. Okay. Now we will discuss a little bit what are the different type of the computing or technology are going to use. So first one is the multicast, already we have discussed. Then wireless sensor networks, internet of everything, cloud computing, grid and cyber physical system and radio frequency identification. So these are the computing already we have discussed. Now we will start from multicast. What is exactly a multicast? There are the three type of the communication when we transmit the data from one node to another one. So first way is you just send via unicast. Unicast means there are the only two system. One system is going to generate the data and second one will receive the data. So the example is called, this method is called unicast communication. Second is the broadcast. In case of the broadcast, we suppose there are the n number of the system connected to one. So one system will transmit the data and all will receive the data. So that is a example of the broadcast. Okay. And third one is the multicast one. In case of the multicast, there is a some group, multiple group is going to create according to interest, and data is going to send from one node to a particular group. So that is called one-to group communication or multicast communication. So these are the three methods. There are the another type of the communication also. We say it the anycast, geocast. Okay. Now this is the one example of the unicast, broadcast, and multicast. So for example, this data is going to send from source to destination. Here there are the source and these are the receivers. Okay. Suppose source send the data to receiver. So it is a one example of the unicast. In case of the this broadcast, source is going to send the data to all connected receivers. So this is the one example of the broadcast. Now in this there are the three receiver, but the two receiver have created one group. So source is going to send the data to two receivers, which is a part of the one group. So that is called multicast one. So there is some systems. For example, there is a source and source want to send the data to receivers. So receiver first join the group and according to requirement of the group, source try to send the data to receivers. So there are the layering system. This layering system called streaming. For example, suppose in our home there is a TV and there are the multiple channel is there. So according to requirement, we select the package, and according to package, there are the multiple channel is going to provided by company. So for example, there is the base layer. Base layer means the minimum number of the channel is going to provide by that is a mandatory. So you need to take those channel that is a provide the minimum kind of the quality or minimum kind of the number of the channels. So here in case of the multicast layer system, there are the multiple stream is going to divide by one main stream. So there is a one data stream which is going to divide into multiple stream or sub stream. We say it the one layer. So base layer is called layer 0 and enhanced layer are the used for providing. Okay. So layer 0, layer 1, layer 2. And there are the receiver side. Receiver will join the layers according to capacity. So this is a called multicast layer system. Okay. Now there are the some challenges maybe happen in a multicast, and there are this is the solution of those challenges. For example, what maybe happen in case of the when data is going to send one node to another one. In case of the multicast, for one to one group. So what may be happen? One case may be happen that all receiver receive the data and there are the one receiver in group which is having the less capacity. Suppose data is coming more than capacity, so that node may be suffer from congestion. So that is the one problem. Second, anyone can send the data into group. Okay. So that is the one question. Suppose we provide the solution, kind of the security for managing this, who is the group or who is the source, then we need to use the key. Okay. So for that, we need the group key management system. So there is a one issue, one problem. We called it the source authentication, means source. Who is our source? Who is sending the data into multicast group? The reason, because the we use the class D for multicast communication, and that class is known to everyone. So anyone can send the data into group. So the solution for respective of that is a source authentication. Okay. So there are the three mechanisms: centralized, distributed, and decentralized mechanism. So there are the penalty of the paper. We can see if we want to work in this area. Now, second part is the group key management. So group key management is used to manage the group of the receivers, means how, who is going to join and who are going to leave the group. So there are the, it may be happen, one member is going to leave and he has the key. After leaving, he or she can receive the data. So we will change the key according to our requirement. When any member will leave the group, so key will be changed. So there are the many mechanisms in group key management system. There are the penalty of the paper. If any researcher is there related to area, he can find out the many paper is there. And third part is the congestion control. So congestion means the receiver may be overloaded due to more data is coming from resource side at the receiver. Okay. So how we control? We control via source base and receiver base. Source base means a source will increase or decrease the size of the stream or speed of the stream, by which receiver will be relaxed and they can manage the congestion. Second approach is the receiver base. Receiver base approach means the receiver will leave or join the group. For example, I am a receiver and I am the suffering from congestion, then I will leave the group. So that is the one example. Suppose I have the capacity, then again I will join the group. So by leaving and joining method, we can manage the congestion. So there are also many literature is available related to this issue. So if anyone is interested in this field, he or she can refer the papers. Now we will discuss the little bit about the your WSN. So in WSN there is a one node, and that node we say it the sensing node. So there is a, for example, there is a some field we will provide the sensor node. We deploy the sensor node. There are the multiple way to deployment. Okay, it is a fixed, manually or random. We will deploy the node in particular field. So those node act as a sensing node. Okay, and they transmit the data to sync. Sync is a one kind of the intermediate device which is connected to internet, and that data is going to provide to manager. Okay, so this manager may be a kind of the system which is going to receive the data of these sensor, and there may be some cluster head or another type of the node, forwarding node inside of the sensor. So this is the one simple example of the sensor WSN. What are the issue inside of this WSN? One issue is the routing, and second one is the localization, security, and deployment. So these are the research issue which is dealing in WSN. And this is the one example of the WSN. We suppose we are going to check the temperature of the cow. Suppose there is a field and there are the multiple kind of the cow exists in that field, and we can put a sensor with this cow, and we can directly check the different value like temperature, pH value, okay, what is the condition of the cow, and that value is going to send to particular one device, and that device send the data to house or whatever user, wherever user is living. Now there is a one example, internet of everything means there is a car or laptop, desktop, electric system. They are going to connect with your internet. So we say it the kind of the internet of the everything. So they act as a node and try to send the data in network. Okay. So internet of thing is the one example of the IOV. In this, there is a one device which is going to send the data to base station, and base station send the data to server or cloud. In this IoT device, there may be some sensors. So what is the major difference between WSN and IoT? In case of the WSN, some data is going to generate by sensor, and in this case also some data is going to generate by sensors. But difference is that this device can take the decision itself. So that is the major difference between WSN and IoT. So that also used in multiple, there are the multiple application, like you can start your fridge, your AC from any place, anywhere with help of the device. Okay, they are the penalty of the application and research issue inside of the IoT. Now, and there are the main issue of these device is security. So we will discuss about this. So there are the three parameters related to security. One is the authentication, and second one is the confidentiality, and fourth one is the integrity. Okay. So suppose we have these different type of the computing or technology, we need to care about these three things. So mainly data security, web security, and channel security is the important part of security. And we apply the command or CIA. So this is the CIA. There are the multiple algorithm exists related to authentication, confidentiality, and integrity. We apply on according to requirements. So there are also many paper related to on this issue. For example, we want to check the authentication in IOV or authentication in WSN. So many penalty of the paper is exists related to this issue. So if anyone is the researcher who want to work in this area, so pick any technology and one security issue and combine and try to find out the literature. Okay. So there are the many problem and solution. Try to work on that. So one simple example of the IoT security is data security is required when we transmit the data from IoT device to base station and cloud. So we required one kind of the security, that is the data security. Our data should be in encrypted form, because if there is some attack happen on that data, so your message will be changed. So your device may be acting differently, that behavior of that device may be changed. Okay, so we need one data security for that case. Again, there are the suppose multiple devices there, then key management will be one issue. Suppose we want to access any cloud with when we are going to connect that IoT device, or we are going to connect our mobile, then we need the authentication one. So this is the one example of the IoT security. So there are the many literature available related to these issues with IoT. Okay. So now I am going concluding to all things. So what we have already, we have the our device, like we have the smartphone, that is a mobile, and we are going to use the network, and we are going to store data on server or cloud. And there are the operating system, and we are going to use Wi-Fi, SIM, wired. Okay. And there are the web page and API for server by which we are going to access the data. So if we are going these smart computing or smart mobile, then we need to care about security part as well as controlling part. So finally, what is our demand? It is smart computing. Already, suppose we are going somewhere in any relative. So what is the first thing we look about the power? Okay, and Wi-Fi. So that is a need of the smart computing. So, but if we are using any kind of the smart computing or any kind of the computing, the requirement is the security. And if you are using the security with any kind of the computing or a network, then one issue will come, that is a overhead and control, how you are going to control it. So we need to, if we are the researcher or scientists and who are working in this area, or we are going to develop any kind of the application, then we need to maintain the kind of the security, and we need to find out the trade-off between security as well as the overhead. So this is the final conclusion of my talk. So my contact detail is this, and we should healthy at the home. Okay, stay healthy, and we should work some exercise at the home. So thank you very much. If there is any question from your side, most welcome.
Thank you so much, Dr. Karan Singh, sir, for sparing time for us. And sir, enlighten the basics issues of multicast communication and also security issues also. So that will really be benefited for our PG and UG students, because sir highlighted the basics of multicast communication and security issues also. Sir, thank you so much for giving your time. And our students, sir has also shared his contacts. So any of our students, if want to take guidance from sir, so he or she is feel free to contact sir. Thank you so much, sir.
No issue. Thank you, Anisa.
Now, our next speaker is Engineer Piyush Tiwari, sir, from eBay Technologies, USA. Sir, are you here?
Yeah, I'm here. Can you guys hear me?
Yes, actually, sir.
Yeah. So yeah, thanks for inviting me, guys. It was pretty much short notice. I think somebody talked to me 2 days back, so I didn't got time to prepare a presentation. But I have like a couple of interesting topics which I think can help whosoever wants to pursue a career in technology. These all are based on my experience. So I'll start with a brief introduction of mine. I had been in this industry for almost 12 years now. So luckily I'm working on like one of the good technologies. I'm part of the cloud team in eBay. So we are working on cloud infrastructure, and because of the virus situation, all the e-commerce companies, they are seeing a surge in demand. So there are a lot of issues we are trying to resolve, and that's like the interesting problems to solve, especially for somebody who's looking into the research and other stuff. Before working in eBay, I worked in a company called Riverbed Technologies. That is also a very interesting company. They work on the networking optimization side. That is also like one of the things when there is a surge in internet, how do you access the data over the lower bandwidth? Like in India, when you have limited data available, how can you basically stream movies or buy something? So that is also a very interesting problem to solve. Before that, I spent a lot of time in Intel. Yeah, and then I did my master's over here as well. So I'll quickly jump on to some of the interesting areas. So I'll try to pick up something which is more relevant. First of all, like when we talk about what technology is the best, I personally believe all the technologies are better. It's just like what is more relevant. So when we are talking about what technology will be good, you have to think about how do you make your life better, right? That's how we define this technology will make our life better. That's why it will have a bigger impact. 10 years back, nobody thought about this big data and machine learning. Now everybody is talking about that. So you have to think about what we have to do that will have an impact after 10 to 15 years so that you can grow on that. Because everybody knows if you talk to somebody now, they will say, okay, big data cloud, they are the best technologies to work in. But if you talk to somebody in 2000, nobody knew about them, right? So you have to basically think about the problem which you want to solve that will help you in the future. So currently the major problems are like there's so much data flowing in the internet. How do you analyze that data? If something goes wrong, how do you fix those issues? So there are like millions of buyers on like Amazon. What if Amazon doesn't work for say X number of buyers? How Amazon is resolving the issues, right? So it's like finding a needle in a haystack problem. So that's like so that's where your like technologies like machine learning and big data comes into picture, and network as well. I heard previous presenters, couple of presenters, they were talking about TCP/IP and bunch of things. Interesting problems are like, if you know the basics, it's much easier to solve bigger problems. So one couple of interesting problems we face in like any of the e-commerce websites which are seeing surge in traffic is like a network bandwidth issue. So one of the interesting problems we are trying to solve, and we solved it before, like I'll pick an example from this meeting itself. There are like around like 200 participants. What if they're like your network is not able to support that many participants, right? So in my previous company, used to work essentially on the network bandwidth with when somebody is trying to download a big file in say Iraq or somewhere where the network is limited. So how do you optimize that? So you can basically compress the data, and like for this example, like if there are 200 participants, they're essentially getting the same data, right? So there's no point in going 200 requests to the server. There can be like say 1 or 2 requests that can go to the server, and all the pending requests can be served by the data which is fetched from the first request. And in case like if there's a like issue with the first request, there can be some timeout or something. So you guys can resolve and all the data is fetched. So instead of 200 requests going to the server and having 200x data, we are having 1x data only, or maybe 2x. So here you have optimized your network bandwidth, because going forward, like network, we will be limited by the network bandwidth itself. Like one of the interesting problems we are solving in eBay, like we are limited by the number of IPs available itself. So if you go to like IP6 or IP4, like in your system, you can support limited number of IPs, right? Public IPs. So we are trying to basically mask like multiple IPs behind one IP, so that there are like 100 IPs behind each IP. So that was one interesting problem we are trying to solve. And one of the good examples which I found from the virus situation was like people like us who are like pretty much savvy into technologies, they want like a very high performing computing systems. It's not possible for everybody to buy that much expensive systems at your home, right? So what a lot of companies are doing, like I was talking to somebody from VMware, so they were telling me they're seeing a surge in like virtual CPUs. So what you can do, you can go onto the cloud and buy the virtual desktop. So you can basically buy it and access it from anywhere. It's a high performance desktop. And advantage is whether you are in India or US, you can access that thing and much faster. And it's much more economical. So it's a win-win situation. So a lot of companies over here, that's how they're dealing with the virus situation. Like instead of like, okay, giving everybody like $3,000 machine, they are buying these virtual desktop, which they can access from their laptop. So it's like another machine onto your laptop without any like issue. Basically, you're not paying for it. Your company is paying a very like the expense is much lower, right? And another thing is like when we are talking so much about the network, from what I realized from a couple of presenters, last 2 presenters, another interesting topic is like the cyber security. So because a lot of data is flowing through internet, so how do you basically make sure that nobody is able to access the data? Like obviously it has to be encrypted. That's not even a question. But the question is like, what if the server itself is hacked, right? So one of the examples is like we are using Zoom meeting, and like 2 or 3 weeks back, everybody was like, at least in US, there was a data breach. So where everybody got to know like Zoom servers are in China, which like most of folks in US were not happy, because servers can be hacked over there. So for the people who are looking into basically solving interesting problem, think about this thing. How will you solve the problem where your server itself is hacked? How do you prevent that thing? Data, most of the encryption technologies, they have like at least some hole. Like people used to use like a 64-bit hash and bunch of technologies, and most of them hackers were able to break it, right? So personally, I believe like a cyber security is interesting thing. And another very interesting thing going over here, which I think is pretty good for somebody who's looking to launch a startup or something in the future, is like digital documents. Like currently what happens in India, if you are basically going, if you want to buy some land or something like that, you have to go physically and do all that stuff, right? Now, basically with the Aadhaar card and everything, everything is linked. That's what at least we are going towards, right? So we can move to a digital age where everything is maintained digitally, including documents. You can digitally sign the documents, digitally maintain the documents. So that's a very interesting idea for somebody who wants to basically have a startup in India. They can have like a digital document management. Like one of my friends, he was working with me. He went to India, he launched his own startup in Delhi itself. So they maintain all the documents for the doctors, like all the reports and other stuff. So it's becomes much easier for any patients if they want to refer to the 10-year older report or 5-year older report, right? And a couple of interesting topics are like cloud infrastructure as of now is like a very good thing because all the data, people want to access the data from everywhere, right? So even your WhatsApp, you want to refer to your WhatsApp photos like which was sent 1 year back, but you might have deleted from your phone. It is somewhere backed up, right? Similarly, your Google Drive or wherever you want to set the storage. So a lot of people had been moving into cloud infrastructure. There are a lot of interesting problems to solve over there as well. So couple of things is like how do you improve the performance of your website? How do you basically able to make sure like in the Zoom meeting that data is streaming efficiently, right? So most probably they'll have a server right over there, like somewhere in India. It need not to go to basically the server in China or US. So basically having the servers close to you. So there's a concept of the edge points. Like Google Drive, you are able to access it very quickly. But Google has like a lot of lightweight servers. They are called the edge points. So wherever you want to send a request to download a document, it won't go to your data center. Data center is like a big beast where your entire data resides. While the lightweight server is where you're like basically only some data will reside. It's like a cache, but they are like much more because they're very lightweight. So you can download the document from the edge itself. So that's why the performance is better. So that's one of the very interesting thing. And if you think about the companies like this Ola, Uber, and Lyft, nobody thought about those 10 years back, right? So, but now if you think about them, they're already working on the next gen technologies. So most of the companies are, at least in US, like Uber and Lyft, they're working towards autonomous driving. So what happens in autonomous driving, because there won't be any driver, right? So you have to think about how do you improvise the things, because if you don't improvise, it will become extinct. One of the good examples is like, if everybody you remembers our Nokia phones, but they don't exist right now because they didn't thought about the improvement, right? And I have like so another, from the technical point of view, I have like a couple of interesting problems we always solve. Was like somebody was talking about the Anycast and Unicast. So in our eBay previously we used to use Unicast. Now we are recently moving to Anycast, because you don't want to be in a situation where you have like certain traffic coming to a certain IP. Say you have 3 IPs and they are different IPs and traffic coming to each of them, and one of the IP goes down. So what you do at that point, right? So obviously there can be like some service in the front which can basically check, okay, which IP is down and do everything. But then there's a delay. So in Anycast, what happens is like there's all the points have the same IP. So even if the one particular IP goes down, basically that particular route will be removed and the traffic goes to the remaining 2 valid IPs. Basically it's remaining 2 basically sets, which is the same IP. So in that way, basically there's no downtime. So that's why in our eBay, we are trying to move from Unicast to Anycast. And like a lot of things we do in basically in eBay is like improving the performance for our users and what we can do better. So another thing is a lot of people like they are logged into Facebook, different social networking websites, LinkedIn, and they don't want to create a new login every time. So one of the things we are coming up, and most of the websites have, you can log in with your Facebook ID itself, right? So that's another thing we have thought about. Yeah, so I think that was it from my side. Yeah.
Thank you, sir.
Yeah, thank you.
We have listened engineer Piyush Tiwari, eBay University, USA. He was described about e-commerce website, limited network issue, how to solve it, network bandwidth, cyber security, cloud infrastructure. This is valuable information for us and researcher. Thank you very much, sir. I would like to invite next speaker, Engineer Shivam Tyagi, St. Joseph University, USA.
Yes, sir. I can listen to you. Am
Most
I
welcome,
audible?
Shivam.
Thank you, sir.
Please carry on.
Yeah, thank you, Rajiv, for inviting me, and thank you, sir, for organizing this. VC sir, Ramapati sir, and all the other organizers. And I also got like the information at very last notice, so I also don't have any presentations, but I would like to put like from my experience, I would like to tell about myself a little bit. So like after completing my computer science engineering degree from our college, I went on to do masters in VLSI design, and then I worked in Food Corporation of India for about 2 years, and then I worked in Delhi Metro for about 4 years. Then now I'm pursuing my masters in software engineering here in San Jose State. So about the topic itself, so it's like we are thinking about the computer systems in upcoming years, in the future generations, right? So how I see it is we should look into the problems that are there and to solve it. And when we move towards that direction, towards solving a problem, we come up with new theories and innovative ideas to solve those problems. So basically it is about identifying problems first. So like in Food Corporation of India, I used to really like, so the work is pretty much manual. They don't have any IT infrastructure that can be used in their operations. So that is a very good like, so all these kind of industries like coal industry or food industry, this public distribution, basically the area where you need to dispatch some goods from one place to another, right? So during their loading operations, they just do like manual stuff, which is very inefficient. And that is one area where technology can be used in like, that is a very open area where you can really exploit it. Coming up to the system, so to have a very good computer system, there are 4 or 5 areas that we should identify, right? So for any computing system, we need infrastructure. Then we need to connect that infrastructure, that is networking. Then after connecting it, we need security and verification. So to security and verification to verify the information and the user. And then we need some decision making processing that comes into play. So if I go over these points again, so when we talk about infrastructure, so Piyush discussed about cloud infrastructure, right? So cloud is something that is coming into picture. Anyone from anywhere can buy a machine on a cloud and then start using it. You don't need a CPU, you don't need to buy a CPU at home, or you don't need to install any software or anything. You just buy it and start using it. It's becoming that easy. I mean, if we want to do something, this is a very ideal age to do it. Like if you want to learn Python, you don't need to install Python. Just go on Google Colab and it will give you an interface. Just start typing the Python commands and you are on the go. So these kind of technologies that are there, they are really ideal in doing something. And I think students should exploit them to their best and just look for anything that you want to do on the cloud. Even quantum computing, IBM gives you a free access to their cloud infrastructure. Just go there, design these quantum circuits and check what the output is there. So cloud is really changing the picture, and it will be of a very significance in the coming future. Then next is networking. So networking, as we see in traditional way, is usually routers and switches, right? And if anyone has worked in networking industry, they must be knowing that, like I used to work in Delhi Metro. So if you install a new switch, you go there manually, physically, and then you configure it, and then it starts working. So this is a very inefficient thing to do. Like, okay, if you have 1,000 switches, it is not like you go to the 1,000 places and configure it. So what is changing this picture is software defined networks, SDN. SDN is something that is changing this. Am I audible?
Yes, sir.
Yes.
You are audible, sir.
Yes,
Yeah,
sir.
Okay, okay, perfect.
बोलें.
Thank you. Yeah. So SDN, software defined networks. So what happens in software defined networks is you have a centralized control and all the equipments that are being connected, you don't have to go anywhere. As soon as they get connected, they will there is a controller or a central processing unit that will sense them and just starts them. You can configure them wherever you are. So that is something like that was a problem that even I faced, but we didn't had that solution. But now it is coming in there, and I think that will be a real game changer in networking technology. So students should look into SDN controllers. Like there are open source SDN controllers, RU controller, and then there is Floodlight controller. Students should actually explore them and research in them. Then security and verification. Yeah. So we a lot of eminent speakers before me, they talked about IoT and data and from sensors and all other. So we have a lot of data. We need its security. So one technology that is really coming into picture is blockchain technology, right? Even Reliance is investing a lot into blockchain infrastructure. So that is something that a lot of research is going in there in its application, and that is one field that in India we should actually start working on, or we should probably we are actually people are researching on it, but if not, then we can start on that. And then last is decision making was one thing. And one thing that is changing decision making is machine learning and artificial intelligence. What you see from the data, to teach that to a computer is something that is really interesting, and it's like amazing thing when you experience that. Okay, you run a script and computer gives you that decision. This picture is good for you, but this is not good for you. You will not like this picture. You should buy this. You should not buy that. So these kind of recommendations, when it gives you, it's really time saving. It saves a lot of time, and it helps you in making a better decision, right? So, and it helps the seller also to make a better sale. So it's like a win-win situation for everyone. So that is one another area that people are working on here in USA. That a lot of research is going on. A lot of research on how you can utilize that. Like one of the most recent project that I came across was they made a app for blind people, and it tells you using the machine learning models that what is going in front of you, and it tells that blind person that okay, there is a car in front of you, or there are people in front of you, and you should walk in or you should go to the left or to the right. So these kind of problem solving things and using these technologies, that will be the future of the computer systems, and we should really look into those research areas. And I will be available. Rajiv has my contact number. If anyone wants to connect with me on any of the topics, I am available for that. I will be happy to help. Thank you.
Thank you, Shivam. We have listened to engineer Shivam Tyagi from USA. He described about the security management, cloud infrastructure, different type of controllers, blockchain technology, IoT. It is valuable information for researcher. Thank you.
Thank you so much, Brijesh sir. Now we have our next speaker, Professor Narendra Kohli sir. Sir is a professor in Computer Science and Engineering Department at HPTU Kanpur. Sir, are you able to hear me, sir? Kohli sir, are you able to hear me, sir? Yes, sir.
Hello.
Welcome, sir.
Okay.
Most welcome, sir.
Thank you. Thank you. Thank you. Should I start?
Yes, sir.
Okay. So first of all, thank you very much that you have invited me. I'm sorry that's just 10 minutes back. I have joined your this session because I was busy in some government work. So as a faculty members, I have listened one or two speakers. As a faculty members, I have prepared a few PowerPoint presentations, and I'll
Disable.
try to explain you.
Disable हो गया, sir.
Are you hello?
Yes, sir. Yes, sir. Your screen I'm sharing, sir.
हाँ, तो आपको सुनाई दे रही मेरी आवाज?
जी, बिल्कुल सर, बिल्कुल सर.
जी सर.
चलो ठीक है. Okay. So I have prepared some PowerPoint presentation. I'm going to explain you a few things. See, first of all, I'll congratulate that you have chosen very nice topic, because our next generation that on systems, everything will be on system and in a fast way. So next generation computing paradigm. So I have specified the things that we are going to use. That one is IoT, that Internet of Things, then is blockchain, then cloud computing, then human computer interactions, then biological computing, then quantum computing. So these are the futures of computing. Next, I'll take one by one and then I'll try to explain you. I think so in your audience, some students are also there, faculty members are also there, and in very simple languages, I have prepared my presentation. So as earlier two speakers was speaking about the cloud computing, everybody knows, and in India, we are using now clouds computing. The cloud computing operate on a similar principle as web-based email client, allowing users to access all the features and file of the system without having to keep the bulk of that system on their own computers. Means you have to, we are hiring the space and the things, right, from the agencies. Okay, so according to the study of International Data Group, 69 of the business are using cloud technology nowadays, right? And the benefits of cloud computing, that is a lot of cost saving, because we should not have to buy where to store or something. Just otherwise we have to change our systems, etc. So cost saving is there. Then security features, naturally the agencies who are providing this cloud facilities, security features are there, flexibilities are there, mobilities are there. Then insight, increased collaborations are there, quality controls are there, then disaster recovery will be there, then loss of preventions, then automatic software updates, then competitive edge and sustainability. These are all the business advantages of cloud computing. Can you change the hello? Hello.
Yes, sir.
Yeah, that's what I'm saying. You just change the things because
Yes, sir.
And a lot of benefits are also there now for to our government agencies because of this cloud computing, because enhanced security is not only the business of governance in the cloud. Rules, policies, and automatic processes can also be applied to financial management. Then cost optimization, the performance management. So these are the things that that are the benefits because of the cloud computing. Next, I told that HCI, human computer interaction. So this is also in futures, and we are going to use human computer interactions. Means how, in which way the interaction between human means users and the computers will be there. Then actually what is human computer interaction is a multidisciplinary field of study focusing on the design of computer technology, and in particular, the interaction between humans and the computers. So this is all about the human-computer interaction. And I have made, can you do the next PPT? I have made some pictures. I think so. Then if it is visible, then you will understand what exactly the thing. Next, please. Yeah, this is the picture. So human and computer. So yeah. So this SC means human-computer interaction is a major role to play in e-governance. Actually, e-government differs from e-governance in the sense that the former is related to the technology, while the latter is concerned with the policy level planning, right? And generally, in this, we are focusing using IoT. IoT means information communication technology, right? So benefits, a lot of benefits are there of using human-computer interactions that increase individual and organization productivity, then reduce health hazards and improve safety, then reduce the cost associated with the development of the user interfaces. Then usability is the main concept in human-computer interaction. That this is the most important thing. Then the usability is concerned with the making system safe, easy to learn, and easy to use. Okay. Then what is the benefit? Means what applicability of SCI, human-computer interaction, to government agencies is that SCI works has a strong impact on government project, and since government policies can influence SCI direction, a durable relationship needs to be developed. And then next, if I'll say for blockchain technology, just now your previous speaker was explaining the blockchain. This is a new concept, and this is very helpful. Means a blockchain is, in the simplest of terms, a time-step series of immutable records of data that is managed by the cluster of computer, not owned by any single cluster, any single entity, I'll say. So each of these block of data means block is secure and bound to each other using cryptographic principles that are chains. Hello.
जी सर, यस सर.
हेलो
You are audible.
ये क्या, ये नहीं, ये क्या आ रहा है? पिक्चर कौन सी आ रही है सामने? ओके, जो ब्लॉकचेन है, हेलो
सर, प्लीज प्रोसीड सर. वॉइस आ रही है सर आपकी? यस एब्सोल्युटली सर.
अच्छा, ठीक है. Okay. Blockchain in manufacturing industry means that enhance inventory management, then improve data security, then better transparency and traceability, then automatic supplier payment, then enhance customer and engagement. So these are the uses of blockchain, and now also there are a lot of research are going on, and we are using blockchains. Naturally, the benefits to the government agencies are also there for blockchain. Means public sector blockchain can build trust, protect data, building trust with citizen, protecting sensitive data, then reducing cost and improving efficiency. As per the NESCOM report, more than 40 blockchain initiatives are being executed by Indian private sectors, and approximate $100 million is going to invest in incoming years in a startup related to blockchain and other emerging areas, right? And major bank in India have joined forces to launch the country's first blockchain-linked funding for small and medium enterprises, SMEs, right? The next is biological computing. This is also very important field, and the lot of research is going on. Then biological computing means such a computing process which is synthesized biological component to store and manipulate data analogous to process in the human bodies. I think so. DNA, you have heard that it has fast computing operation with higher accuracy and precision. Main biological component using biological component computing is DNA. Means DNA computer is a molecular computer that works biologically to solve complex problems, and different possible solutions are created at once. And the benefits, lot of benefits are there in that storage also, means dense storage. 1 gram of DNA that is 2.2 petabytes. It means 2.2 into 1000 terabytes, right? Parallelism can also be used in this. Then extraordinary energy efficiencies are also there. Naturally, for government policies also to be implemented, that medical and health department for treatment of critical diseases, we are adopting that thing. Still, a huge investment has to be done for bringing down it in a practical for a practical way, right? Main advantage of this technology over other like technology is the fact that through it a doctor can focus on or find in treatment only the damaged or diseased cell, not otherwise the things will be open and then the doctor is seeing what exactly the problem is there. In this, using this biological computing, only the damaged and diseased cell will be treated, okay? Then the next, just the earlier speaker was telling about the quantum computing. This is also very important future technology. The classical computer, it was there, but now the things are coming back. Exactly, we are using 0 and 1. So to crash through operations, but quantum computing use quantum bits or qubits. So this is the difference between general and quantum computing. And the benefits are that quantum computers are great for solving optimization problems, from figure out the best way to schedule flights at an airport to determine the best delivery route for the FedEx truck, etc., etc. Produce 2.5 exabytes of data. So that number is equivalent to the content on 5 million laptops. So quantum computer will make it possible to process the amount of data we are generating in the age of big data that Google says. And naturally, this helps, quantum computing helps to the business and the government agencies also. Means quantum computing help resolve issues around healthcare and policy outcomes, but technology, academia, and government need to collaborate to make them truly useful. Okay, and in the budget of 2020, this our finance minister, Shrimati Nirmala Sitharaman, she told that the new economy is based on the innovations that disturb established business model, artificial intelligence, IoT, 3D printing, drones, DNA data storage, quantum computing. So naturally, our government sides also, they are promoting these type of technologies. Okay, so the last that IoT means Internet of Things. I think so. Nowadays, we are using a lot of Internet of Things, which in innovations, incubations, innovation, startup, we are using this type of things, which are once positioned as a niche technology for a startup is today to go to technology for enterprises who deserve to transform their future business. To the value of 1.7 trillion dollar at the end of 2019, and it will be goes up to 11 trillion to $2,000 to 2025. So the key return driven driver for 54% of enterprise IoT project is saving on cost, and other include enhancement in productivity as well as on the whole work safety. Okay, so this is the benefit. If I conclude the things, the next PPT you can show, it is useful in use of smart devices, reduction in operational cost, then achieve customer centricity, then gathering rich data, then enhanced security measures. So these are the benefits of IoT, and naturally government agencies are also promoting such type of things. A lot of nowadays in the age of Corona, and our government also promoting a lot of funds, means give funds also for small industries. So these technology, we have to use these technologies, and so that the things comes in a faster way. Okay, so this is all about what I have planned to explain you. So these are futures, and these are the technologies that in next generation we are going to use. So this is all about from my side. Thank you very much.
Thank
Hello?
you so much, sir.
Thank you, sir.
I don't know. Okay, so
We have listened to Professor Narendra Kohli, sir, SBTU Kanpur. He described about cloud computers, human-computer interaction, application and benefit of the human-computer interaction, new thing, biological computing, quantum computing, IoT-based technology. This is valuable information for researcher and student. Thank you very much, sir.
okay, thank you.
Thank you, Kohli sir, for always being a part of IT and guiding us at time to time, sir. Thank you so much, Kohli sir.
Okay, thank you. I'm sorry that because of internet problems, some lagging may be there, but next time we'll see if it is.
No issue, sir. Thank you so much, sir.
Thank you, sir.
Okay, thank you. Okay, I have some work now. I'm leaving.
Okay,
session.
sir.
Okay, thank
Okay,
you.
sir. Thank you, Manisha. I would like to invite next speaker, expert member, Dr. Anupam Singh, Associate Professor, UPES, Dehradun. He described about the next generation computing system. Are you here, Anupam Singh?
Yes, yes, Bharadwaj sir, thank you.
Sir.
But I have to share my screen first. I have to share my PPT.
Most welcome, sir.
So is there any delay in my voice?
No, sir.
No, sir. No, sir.
You are clearly audible,
Okay.
sir.
But I have to share my PPT, and that is not seen here.
Sir, it is
Yes, sir, you can share, sir.
screen sharing is enabled from our side, sir. Please try, sir.
Okay. No, it is whiteboard, then iPhone. It's available on desktop.
Sir, screen शेयर के बाद सर उसमें स्क्रीन विंडो बन के आएगी सर, उस पर क्लिक करिए तो सर शेयर हो जाएगी सर।
No, that is Rajiv's screen.
Just a second, sir.
सर आप सबसे पहले अपने विंडो पे जो आप दिखाना चाहते हैं उसे खोल लें। उसके बाद आप स्क्रीन शेयर पे जाएं। जैसे ही आप स्क्रीन शेयर पे जाएंगे, जो चीज आप शेयर करना चाहते हैं वो शो कर देगा सर प्लीज।
Okay, okay. Okay, thank you for okay. Again, good morning everyone. First of all, thanks to all organizers, especially Bharadwaj sir and Rajiv sir and all other members of the team. Thanks for this webinar in this pandemic situation, because learning should never stop. I'm Anupam Singh, Assistant Professor in University of Petroleum and Energy Studies, Dehradun. Before going for the topic for today's session, let's discuss about the basic things. I'm audible to all? My voice is clear?
Yes, sir.
Okay, thank you. Thank you. Okay, so that is the overall agenda for today's talk. We will explore the basics of history of computing. Then what is the motivation behind next generation computing, in which we will see optical computing, nano computing, quantum, molecular computing. Then we will see the verification methods and specification methods, that is called formal methods. And at the end, we will see trending technologies of today's era. So start with the first from the Neumann machine and Alan's Turing machine. Approximately 50 years passed away, and today we are discussing about the basic things of computing. So computing started approx 50 years back in computer science, but till now the basic methodology is same. We are working for computation on through computers, but algorithms, procedures, these are the key parts by which we can think upon any solution. We can share our ideas to professional world, and as demands on computing, storage and communication continues to escalate, that creates the requirement of new technologies, new era, and that creates the requirement of next generation computing. So motivation behind the next generation computing is the limitations behind the conventional computing was, that's why rethinking is required. For the benefits of society, we have to explore novel ways of transformation as computing demands changes day by day. So that creates the curiosity and that creates the requirement in the global market. So how to rethink it, how to research it, that creates the requirement, and by which we got the term next generation computing. In next generation computing, we will see optical computation, then nano computing, biological inspired computing, quantum computing, fog computing, edge computing, cloud computing, and many more. So start with the optical computing. Optical computing is based on basic working of photons. Optical computing is the use of photons in computation. Photons effectively massless and incredibly fast are generated using diodes or lasers. The photons take the place of electrons in more traditional computers and are used to represent the flow of data. So that is basic with photons. Now I think next is nano computing. Nano computing is a term used for representation and manipulation of data by computers smaller than a microcomputer, because that means that length is quite smaller in terms of nanometer. So so the current devices are used utilizing transistors with channels below 100 nanometers in length. So that is related with nano computing. Next is I'm giving you just a basic brief on these topics. I'm not going in more detailed format because the platform is limited and we are getting limited time. So that's why I'm just opening up the terms and you have to explore it more. In future, we will see in detailed format. Next is quantum computing. And if we talk about quantum computing, because that starts with the basics of quantum theory, the problems that are out of reach of classical or conventional computers can be solved through quantum computing, and that is depend on quantum mechanical properties of devices. Now, quantum devices and quantum techniques have attracted significant interest from researchers and audience. That can take place in the solution part. Now, moving to molecular computing, that is again part of the computing in next generation. Molecular computing is basic, that is depend on the DNA molecules. The working means we can program the DNAs for computation. So that is simply, in simple line, we can say like living cells can be programmed, and that is the basic behind the molecular computing. Now we are moving to a new term, although this is not new one. Formal method is the older one, that is approximately 50 years back concept, that is used for formal verification and computation to verify the computation process. That is a method, formal method is formal specification and verification to check whether our system is correct or not. If it is correct, we can move on. If it is wrong, we have to remodel it. So formal methods are mathematical notations by which we can model our system that works in all possibilities. If it is 100% correct, then we can move to apply in applications. Otherwise, if you are not, although it is costlier, if it is more costly, if we are going to solve, for example, we are going to model a lift system. So we have to define all specifications for lift working. How many floors are there? How many means how many lifts are there? And if it is available at second floor, what is the possibility whether it goes to first or third? So these are the possibilities of movement of lift. We have to specify all possibilities, then we can move for formal specification, and after specifying all possibilities, we can go for verification. So formal methods is, although it is costly, I'm repeating my line, it is costly, but it can be applied for all applications. In that case, if we are going for 100% correctness. And there are multiple algorithms that are known, approximately 200 years back algorithm that has been verified and got its acceptance through formal modeling. Event B is a formal method by which we can specify distributed framework, because if you, I think you will, other speakers have given an idea about blockchain. So the background behind blockchain is decentralized distributed system. So decentralized distributed system, I'm not going in more detail. You can think like a discrete system or discrete, if you have idea about discrete mathematics. So the event B provides a framework by which we can work for modeling on discrete structure or discrete systems that are in discrete manner. Event B is one formal method by which we can formally specify a discrete system. Rodin is a tool by which we can specify event B specifications, means B specifications we can write through Rodin tool. This is Eclipse based framework by which we can write specifications written in discrete manner. So on this tool, there are multiple proof obligators. Some provers are available like Atelier B. So these are the two components of Rodin tool. One is a static part and second is dynamic part. The static part gives us basic things, what are the boundaries in which the complete model will be defined, and dynamic part is machine in which all events are defined by which the complete modeling is handled. Context has sets constants, oxims. This is complete mathematical format. So formal method is not a theory concept. It is complete mathematical format that we can use for modeling. So in context means the static part has things like sets, the concept of set theory, constants, oxims, in machine variables, invariants, theorems, and events. These are the key parts of these two areas of modeling. Now machine sees context means machine sees the boundary in which it executes, and machines can be redefined means it can be refined as per requirement. So if new requirement came from user, it can be redefined further means it can be refined. And again, the refined machine sees the context. On the basis of the context, the actual machine executes accordingly, and in future, if it is required further, it can be redefined. Now we are moving to the trending technologies. These are the some buzzword in today's era. Because the agenda of this webinar is computing. The term, if we can talk single word, the term is computing. So we have seen molecular computing and optical computing, right? And so if we are going for blockchain, because that is a buzzword, so the background in blockchain, the computing that takes a higher role is fog computing, cloud computing, and edge computing. Although cloud computing is not a new concept, cloud computing is an older one, but fog computing and edge computing is part of any cloud network. So we will see some brief format, and 5G is a 5th generation computing. So we are going for one by one in shorter form because time is limited. So blockchain, what is the blockchain? So if we think Hyperledger, I think you have heard. Ledger, if you have seen like Bahi Khata that we can use. So that is the term that is exactly used with the word blockchain. Blockchain could be regarded as public ledger, or you can see it Hyperledger, and all committed transactions are stored in a list of blocks. These are 3 blocks like block I plus 1, I plus 2. So these are the blocks. This chain grows as new block as appended to it continuously as per transaction come in picture. It is verified, then it is added to the blockchain. Asymmetric cryptography, that is used for hashing. Asymmetric cryptography are distributed consensus algorithm that have been implemented for user security, so that it can. That's why we got one new property of blockchain is immutability. The blockchain technology generally has key characteristics of decentralization and persistency. So these are the this is one idea. Means, for example, we are getting T1 transaction. So T1 is added, and the first block of any blockchain is called as Genesis block. After that, then when the next transaction came in picture, it is first verified whether it is correct or not through miners. Then it is added to the existing blockchain. If it is okay, then it is added. But there is no centralized system behind blockchain. This is completely decentralized system. Now next is fog computing. If we talk about what is fog, so just realize with the real word what is fog. Fog computing is a paradigm that extends cloud computing and services to the edge of the network. So you can see through diagram F1, F2, F3, these are 3 fogs network. You can see it as a network. E1, E2, E3, E4, E5, E6, these are edge. So that is also part of one fog. So for F1, the edges are E1, E2, means these are end devices that are connected with the fog network F1. Likewise, F2 and F3. And F1, F2, F3 in combination defines one cloud. So fog computing is one buzzword that is in background of cloud computing. Next is edge computing. So what is edge computing? Edge computing proposes a novel model for providing computational resources close to end devices that are connected to the network. So if you can see this diagram in blockchain, the background is edge nodes. So any node that is available at the bottom one in the previous slide. So this is the last layer in which smart things means smart devices are available. So edge computing means edge nodes are used so that we can define a new transaction, and new transaction is added with the blockchain through edge nodes that are smart enough. So at this point of time, I will conclude my talk with the things like computation has no boundary. On the basis of input, computation can be performed, and next generation computing has changed the thought process of mankind. So we can think some in different way, means out of box. And at this point of time, I will add one more line, that is my submission. Next generation computing society is defined in 2013 at UPES. That is one society that with the same name, Next Generation Computing Society, available, that is completely functioning, working at UPS from 2013. And in this pandemic situation, we have to help others in COVID-19 situations. What is the most possible way in your nearby, what you can do your best. And thank you from my side, it is done. My email ID is written. So if you have any question, any doubt, you can ask. That was all about. Stay safe, stay at home. Learning should not stop.
Thank you very much, sir. Thank you, sir.
Welcome.
We have listened to Dr. Anupam Singh, sir, from UPS, Dehradun. He described about very knowledgeable information for optical computing, nano computing, molecular computing, fog computing, edge computing. These are technology are very useful for the faculty members and research scholars. Thank you very much, sir.
Okay, welcome.
I would like to invite to Dr. Sudeep Tanwar, sir, Associate Professor, Nirma University, Ahmedabad. Please join us, sir.
सर वो अभी
प्लीज अनम्यूट सर।
ज्वाइन नहीं किए हैं सर वो हाँ सर वो प्रेजेंट हैं लेकिन ऑडियो ज्वाइन नहीं किए हैं सर वो
प्लीज कॉल
Yes, sir. I have talked to Sudeep Tanwar, sir. He is joining by audio now, sir. He's trying to connect, sir. So really, it is a very great experience for all of us. And we are providing an opportunity to our students and researchers like us to have eminent speakers, a galaxy of speakers with us. And sir, I would really like to thank till the time all the speakers. They have presented really well and they have shared their new ideas and trends what we are having in next generation computing system. So I really thank to all the professors who have shared their ideas with us. Thank you, sir. Sudeep, sir, are you able to hear us? I think there is some issue. So I will try to call my next speaker, and later on, when Sudeep sir will join, I will try to accommodate him. So our next speaker is Dr. Anamika Singh ma'am. She is Assistant Director in IGNOU Lucknow. Ma'am, are you able to hear us?
Yes, ma'am, I'm able to hear all of you. Am I audible?
Yes, yes.
Yes, madam.
A very good afternoon to all the galaxy of the experts, scholars, and eminent learners who have joined today's webinar. As we could see in today's webinar, the experts have discussed about the development of computing system from first generation of the computers to the fifth generation of the computer. But being associated with the field of distance education, I would like to emphasize how this development of computing system has helped in the promotion of distance education. So the topic of my discussion is distance education and role of e-learning in the present scenario. Distance education, as we all know, focus on an open access to make the learners free from the limitation of time, pace, and place, and offer flexible learning opportunities to the individual or group of learners. It can also be said that distance education has made the education system classroom-less or boundary-less. Institutions of distance education have adopted different multimedia approach of learning, for example, teleconferencing, video conferencing, self-learning materials, audiovisual aids, radio counseling sessions, and face-to-face counseling session to bring the education beyond the boundaries of the campus. Whereas e-learning or electronic learning is a type of education where the medium of instruction is modern technology. There is no personal contact required for communicating with the people. E-learning has brought the education into a virtual world by using applications and processes like web-based learning, computer-based learning, virtual classrooms, and digital collaboration to impart skills and knowledge. By looking at the characteristics of both the learning system, it can rightly be said that distance learning and e-learning are complementary to each other. E-learning is looking up as a tool for boosting up distance education, and both together can increase the gross enrollment ratio, GER. The purpose of implementing e-learning with the distance education is to take the education to the doorstep to the working professionals, unreached section of the society, the rural poor, disadvantaged and marginalized people of the society. E-learning based distance education enables learner to become proficient in upgraded knowledge, skills, use of new technology, meeting the challenges and enhanced learning with the strong academic skills. Where the Government of India also keen to utilize the technological resources in helping its mission to make education, specifically the higher education, accessible to all the deserving learners. Government of India has launched National Mission on Education through Information and Communication Technology to benefit all learners of higher education in any time and anywhere mood. It plans to focus on appropriate pedagogy for e-learning, providing facility of performing experiments through virtual labs, online testing and certification, online availability of teacher to guide and counsel the learners, utilization of available education satellite, EduSat, and improvement in and DTH platforms for training and empowerment of the teachers for effective use of new methods of e-teaching and learning. Most of the distance education institutions have adopted these technology-enabled e-learning platforms for imparting education. Virtual classroom is one of them, where latest multimedia approach is utilized as instructional pedagogy for its learner. Online counseling is a step forward towards learner-centric education, as it provides anywhere, anytime counseling for those who cannot attend the counseling session at the college and study centers. Even in this present scenario of lockdown, where everyone is compelled to maintain social distancing from each other, all the academic activities, not only of the higher education, but also from the primary and secondary education, has put on hold. And here, this e-learning platform has come as a help through distance mode, like all the primary, secondary, and higher education is being provided through e-learning. Like you can name them as a Google Classrooms, as Zoom app, as Google Meet, WebEx, etc. And we are providing education to the learners through distance mode only. Not only this, the webinars which are being arranged and by different institutions are also using this online platform in a distance mode to connect each others and share the views on different issues. Some of the platforms for imparting distance education through e-learnings are massive open online courses, also known as MOOCs, which bring online courses free for all and provide certificate on completion of all major components of the course. VYAS, Web-Enabled Academic Support of IGNOU, is also an e-learning initiative for the learners of distance education. National Program on Teaching Enhanced Learning (NPTEL) is a project of MHRD to pave the way for introductory multimedia and web technology to enhance learning of basic sciences and engineering concepts. MedVarsity is India's first medical e-learning program. Swayam Prabha provides an opportunity to view digital courses on TV. Center of Online Education COE of IGNOU is coordinating the running of 5 TV channels of education. eGyan Kosh of IGNOU is a national repository of books developed for sharing the learning contents. Gyanvani and Gyan Darshan of IGNOU is also utilizing the same online platform for imparting education. Along with them, ePG Pathshala, Shodh Ganga, eShodh Sindhu, eYantra are some of the other e-learning platforms which provides education through distance mode. The cloud computing and the other e-learning platforms which we have discussed till now are just the mode of providing the education to all the learners through the distance mode only. So we can say, as education is the biggest challenge faced by India at the present time, and it is the only distance education through its various learning platforms, e-learning platforms can ensure the availability of education without any social, physical, and geographical restrictions. Thank you.
Thank you, madam. Dr. Anamika Sinha, Assistant Director, IGNOU, Lucknow. She provided very knowledgeable information for web computing, e-learning, online courses, distance education. This is valuable information for us. Thank you, madam.
Thank you, sir.
Next, I would like to invite Dr. Sudeep Tanwar, sir, Associate Professor, Nirma University, Ahmedabad.
Madam, just open this screen share you have disabled.
Okay, sir.
Just enable it, okay?
Sir, it is enabled now.
Okay.
Most welcome, sir.
Thank you, sir. Thank you. Now my screen is visible to all of you?
Yes, sir.
Yes, sir. Let me just make it full screen. Okay, so good afternoon to all of you.
Good afternoon, sir.
Myself, Sudeep Tanwar. I am from Nirma University, Ahmedabad. And it is very tough to take keynote or as a lecture in this tough time because normally it's 2:30 now, it's lunch time, okay? But be with me for next 10 to 15 minutes. Hopefully I'm not going to bore you. So in this presentation, because this webinar is on next generation computing system, so I have kept my presentation with respect to the healthcare scenario. So what will be the role of this next generation computing system for the upliftment of the healthcare solutions, okay? So the agenda of I have divided my presentation in 3 parts, okay? The first I am going to highlight what is the role of this artificial intelligence in this pandemic situation, COVID-19, and what as a researcher we or some of the students from your university or from my university or across the country, they are going to provide the solution, okay? And second, I'm going to highlight what is state of the art in the unmanned aerial vehicles, how this technology unmanned aerial vehicle is going to help you in this pandemic situation, COVID-19. And then I'm going to highlight some of the issues that should be handled with the adoption of blockchain technology in this pandemic situation, and some findings and some takeaway, okay? So just to start my presentation,
Sudeep, sir? Sir, are you there?
Sudeep sir.
Sir, we are getting you. Please speak, sir.
वॉइस नहीं आ रही साहब की.
नेटवर्क इशू.
सर को फोन कर लो, फोन.
Yes, sir, I'm trying.
बहुत इंफॉर्मेटिव है सर का, लेकिन सुन नहीं पा रहे हम लोग.
सर डायरेक्टर सर, जब तक सर जुड़ नहीं रहे तब तक आप ही सर कुछ वेलेबल इंफॉर्मेशन सर प्रोवाइड करिए.
All are very learned people in front of us, and certainly I am also eagerly waiting for Dr. Sudeep sir in the opening address. As I said that आर्टिफिशियल एंड डेटा माइनिंग ने इतना बड़ा रोल इस कोविड में भी किया है, जिसे डॉक्टर सुदीप सर अभी हाईलाइट कर रहे हैं, रोल ऑफ आर्टिफिशियल इंटेलिजेंस. इसके बारे में मैंने सब्जेक्ट को अबाउट द सेमिनार बताते समय ही बोला था. 30 दिसंबर 2019 को ही, अगेन रिमाइंड यू, 30 दिसंबर 2019 को नॉट एनी ह्यूमन बीइंग बट आर्टिफिशियल इंटेलिजेंस बेस्ड हेल्थ मैप वेबसाइट ने, सब आ रहे हैं क्या?
Sir, I talked.
क्या बोले वो?
I talked to Sudeep sir. Actually, उनका switch down हो गया sir.
अच्छा, उनके यहाँ डाउन हो गया इंटरनेट, तो उनसे कह दो कि आ जाए.
जी सर, he is trying to connect sir.
ओके, लेट हिम. तो उसमें वो जो न्यूज़ पोर्टल है वो एआई बेस्ड डेटा माइनिंग करते हुए न्यूज़पेपर्स की रिपोर्ट देखता था, और उसने चाइना के सिटी ऑफ वुहान में जितनी न्यूज़ को स्कैन किया और उसके आधार पर डिसीजन लिया और कन्वे भी किया कि न्यू टाइप ऑफ इन्फ्लुएंजा अट्रैक्ट्स द अटेंशन ऑफ डॉक्टर्स. लेकिन जैसे कभी कभी हम लोग बात बना कर देते हैं ना कि अभी ऐसा नहीं आने वाला है, इट वाज इग्नोर्ड दो मशीन डिटेक्टेड इट मेकिंग रेड अलर्ट, and this warning was echoed on 30 December 2019, whereas after 1 month, that is on 30 January 2020.
Sir.
Connecting.
Sir, I think Sudeep sir is taking some time to connect. Till the time, can I call Dr. Rakib sir?
Next speaker.
Yes, sir. Sir is from Firoz Gandhi Institute of Engineering and Technology, Raebareli. Sir is working in MCA department. Sir, are you able to hear us? Unmute. Yes, sir. Sir has started sharing the screen. Yes, sir. Your screen is visible to us.
क्या नाम है? राकेश मिश्रा.
Hello.
Yes, sir, you are
Hello.
audible. Yes, sir, you are audible, sir.
Good afternoon. Very good afternoon, and let's start this particular. Thank you for inviting, and let's start with this scenario. Now, today, what I am talking not about the computing system, but where we need the computing to be actually implemented. Okay. Now, the very first thing is how we are going about in our real life. We are talking through the cellular network. We are organizing through the network itself. And a lot of network is in our life through smart cards, through our RF tags. So the commercial paradigm says that we have to first see how these things are being utilized and how the things can be seen from the user's perspective. So this is first thing is we have a cellular network. This network is primarily comprising of 3 generations as of now. The first one is of the 2G, which is, we are calling it obsolete, but still existing. 3G, which is sometimes serving us in some areas. And the 4G, which is prominently being accessible to all of us nowadays. How we are using this service in a form of video calls, voice calls, utility apps, say for the payments, for news access, for everything. There are a lot many utility apps are existing on there, and journal browsing for internet access. Now still we have 3 generations of network, but the quality of network is still a very serious challenge for us. Uncertainty always persists. An example, couple of minutes before, we have seen that the uncertainty leads to rescheduling of the events. So how can these 3 or 4 generations of the network can combine together or can be analyzed together to form a homogeneous space of communication? Am I audible? Am I audible?
सर
यस सर
सर आवाज आ रही है सर
यस सर आ रही है आवाज
हाँ ठीक है, thank you. So we have 3 these networks existing together, and the service what we receive is often of not of very satisfactory nature that we have seen always. So we need to design a computing paradigm that integrates all these 3 in a one forum to make us have a seamless connectivity and easy accessibility. The second thing that comes to our existence in nearby is a WiMAX. WiMAX you might have seen on your rooftop, like a thin aerial which has a mesh on the top. So that particular thing is a WiMAX. AirRail is starting a WiMAX services, and your BSNL is having a WiMAX services. Now this WiMAX is used for the metropolitan connectivity, that is the city-wide connection, backbone connection, wireless. Now this is another infrastructure which is existing altogether differently from your cellular network. Even though the operators are same, but their billing and infrastructure, it is all different. And moreover, in comparison to cellular network, it is having a higher capacity and larger reach. So this is the area. And what we are using with this, we are basically using it for MSMEs, that is the small and medium enterprises. They are in the remote areas. They are using this particular service for internet access. And Industry 2.0 standard, that is the industrial IoT, lot much depends upon the connectivity from this. Now, this is what we have in our home, the Wi-Fi network. This particular network is being used for office automation, home automation, and lot of different things, video streaming, audio streamings, live connectivity. So this network is basically putting all our life to ease in our space, in our homes,
and in our offices. Moreover, expanding the wireless accessibility of the internet is again an area. So this is the third network which is we are using. So we are using the cellular network, we are using the Wi-Fi network, we are using the WiMAX network. This is the next generation of users, smart vehicles, smart transport, which the people were talking earlier. Now, what is happening over, this is something very different from previous generations. In previous generations, we have a lot of centralized control. There is somebody which is looking after who is going to be connected and how it is going to be connected. In ad hoc network, we don't have any connectivity. This autonomously, one of the nodes here in this picture, it is a car or a drone, which take charge of connections and start acting as a coordinator among these. Now the problem comes with this particular type of network is what is the scale of this particular network? Whether it should go for a 2-hop, 3-hop, or what should be the size of that network? And data losses is one of the things that can happen here. But still, this is more important because next generation smart transport require the existence of this to maintain a collision-free traffic at the roads. Similarly, when we have a surveillance, we need multiple drones monitoring the larger space in a synchronized manner, putting up a constant feed. So they should remain in a distance, in a coordinated manner, in the space to feed us the correct situation on the ground. This is something new that we are seeing nowadays, near field communication. And this is happening. Now you have seen an ad of contactless cards. A card which is being just put on a POS and money is deducted from your account. Now this is a near field communication until unless both the things, the card and the POS, don't come in close proximity, then nothing will happen. Say 2-3 centimeter or 4 centimeter of range, then nothing will happen. So that is why it is called as near field communication. Similarly, some time back, you might have seen a data exchange between the two phones by shaking it. It was, if I'm not wrong, it was a Samsung's utility being extended. Metro cards and metro tickets. These are the things that we have already seen in Delhi's and lot of many metros where we are just putting a card on that or the ticket in form of a coin onto the entry gate, and that gate allows you to go in. Then it's a parking. Parking is relatively new to us, although it is very old in Western countries, but it is relatively new to us because we damn care about parkings. But the parking is now becoming a serious business. So parking management is becoming a next generation near field communication systems. And in the financial sector, what is coming up is the cardless ATM. So you are just going to the ATM, pushing up some credentials, and the machine will be vending you the money. So this is a one set of use which is having another kind of computing requirement. The FASTag that you have seen is now being enforced in all national highways. It's a RFID based system, a small smart chips, which basically connect with the local server, and that particular ID is connected to your bank account and tariff is deducted from your account itself. Herein, the banks are directly involved in the marketing of these RF tags. So when bank is involved, your tag and the bank account is directly getting associated with that particular your asset. So it is again one thing. So there is something that happening in our day-to-day life. There is something happening on the national highways. There is something happening in the telecommunication, and all these things are happening in isolation and independently. Now, the most recent thing and most happening thing in India is the smart grids. The smart grids, basically the integration of all the power supply unit, generation units, conventional, non-conventional, nuclear, thermal, everybody into a one unified communication setup and billing setup also. So the primary objective here is to offload a grid, to protect a grid from certain surges, to maintain a supply within a grid, depending upon the load expectancy and all that. So there is again a very huge computational requirement out there in for smart grids, where the power line communication is playing a very great role. And why I'm calling it a power line communication, because the wires that you see on the, whenever you have a chance to go out in a highway, you see you have a cables, and beneath the cables, there is a guiding wire which is running. So that particular guiding wire is basically a communication line between the two substation or major power stations. Now the things get more magnified and little bit more larger when the power line communication decides that I want to shut a particular load. I'm not going to shut the entire load. I'm going to shut a particular load. Say, for examples, can I shut down the ACs for 2 hours? Can I shut down the heaters for 1 hour? So these kind of things are the next thing that the smart grid is basically planning to implement. And we need a huge computational power to decide on this, how to make or avoid complete blackouts in the city, because complete blackouts in the cities make the city vulnerable for the accidents and crimes. So the partial shutdown is an area where the people now smart grids are working. Now, what all this finally scenario lead us to? Very first thing, I, the user, is using the telecommunication network. I am an industry or an executive at MSME. I'm also using the WiMAX services. I have lot of home and office automation implemented. I have smart transport system in most of the cities, and some of the cities automatic challan systems have already been implemented. Say in Kanpur, Lucknow, we have these things being implemented. Delhi is already having that. So vehicle safety, transport, these all are basic, putting up lot of efforts. FASTag and contactless operations. In case of what we are facing right now with this Wuhan virus, we have to go contactless. Otherwise, we will be sitting in the same hall together. So we have to go for a contactless operation as far as the access of service, finance, and anything is concerned. And then we have a smart grid where we have a smart meters, which are giving us a metered supply as we have in the phones. Now, what all this together means for a single person, if he or she is using all these services, they have to push a lot of efforts to pay the bill independently and segregately. Second thing is there is no coordination among the different infrastructure to understand the surge in need, surge in demand. There is no coordination among the infrastructure to make it fail safe or recover from breakdowns. So there is a need to first create a common access point to have this services. Now this is very common thing. Let's do the cloud. Now question comes, how the cloud is going to help us. The very first thing the cloud is going to offer us is a huge platform and huge capability to do independent processing for the individual infrastructure, plus it can be integrated over a common pipeline. Now this thing and this capability of cloud computing can be helpful to pull the cellular network, the WiMAX network, Wi-Fi network, and your near field communication for quick payments, FASTag into a one virtual entity which represents a user. But the problem comes, can cloud do everything? Is cloud having an enormous capacity to handle every kind of integration? So answer is obviously no. The cloud doesn't have that much of capabilities to address everything. And moreover, if we go for a conventional approach, the cloud will be overloaded in some, say, 2 years or 4 years down the pipeline. So what we need now, we want to add to the cloud the AI platforms. The cloud is acting as an integrator, and another cloud which is basically running all the artificial intelligence algorithms to support, to respond the integrator in a seamless manner. So we have two kind of clouds together working. One cloud which is acting as an infrastructure aggregator, where all the infrastructures are aggregated and all the data streams from the aggregator pushed onto the AI platform. So these are high performance two clouds integrated. Now, why I am looking forward for our AI specialized clouds? Very first thing is from the perspective of telecom, which is very close to my heart, because I'm very much frustrated with always looking into almost bad or near to bad quality of network and unpredictable behavior of the network. Sometimes it is very good and sometimes it is very bad. So what is the optimal performance? So here the AI can understand how can I offload, that means put or distribute my user base into the 3 different generation of the network. If somebody wants to make a voice call, it is not necessary I want to give him a 4G network. I may push him to 2G network. Okay, you talk. My phone can work on a 2G because we have the compatibility with us. Similarly, if somebody wants to do the browsing, that is non-thrusty application, which do not require the very high bandwidth, we can push it to the 3G and leave 4G exclusively for video calls, YouTube streams, or any kind of high bandwidth application. Moreover, to the cloud interfacing, because cloud again demands a specific bandwidth. Until unless the bandwidth is not there, you cannot connect your phone to the clouds. So this can be done by deploying AI for the telecoms. Now, how can it be done? It can be looking into how the people are using it, what is the data requirement at any point of time, what is the variety in the data requirement, and what is the expected, and that is the role of AI. Similarly, decision and control is again another factor which is existing everywhere. We need a decision how to shut down our power supplies. It is not like that, switch off kar do or sabko band kar do. No, there has to be some controlled access so that people are not blind completely. Second thing is, we have water supplies. How can we regulate the water supplies? Third part is, we are using the smart systems. Do we need a continuous connectivity with our homes and offices to do the smart working, or we can have some leverage of delay to perform the task. So this is something that can be done by integrating the office automation part, your home automation part, and your near field part. Say for example, near field part, what I'm saying is NFC. Now, whenever I'm in a parking lot, if I am close to a parking lot and working in a vehicle, the system must be ready to make a sharp connection between the parking lot and my phone so that the payment can be done in a required time space. Who is doing this? So what it can do for us, optimal resource utilization is one of the things that cloud along with the AI can do for us. In case of multiple clouds offering different kind of integration and aggregation, they can provide us the seamless integration. Hello? Sir, can you tell me who is drawing these arcs? I'm not touching my phone.
Yes, sir. We are trying to detect, sir. Just a second, sir. Disable all the participants.
Both hands are free and still these are drawing.
Yes, sir. We are able to see, sir. We are understanding, sir. So now try to share your screen, sir. I really apologize, sir, for inconvenience caused to you, sir. Sorry, sir, please.
It's fine. So what it can do, it can help us to optimize our resources. It allows us to share data from telecommunication to my financial transaction so that there is no delay associated with it and everything goes very smoothly, or connecting my telecommunication network of requirement to my parking lot requirement so that I don't have to wait, or integrating my communication requirement to the RF tag so that I don't have a much time to wait on a highway. Another part is the data mining, which is the most crucial part with the AI, because AI has to do a lot of data analysis. So data mining is again handling of volume, because we are not crore or 2 crore of peoples. We are around, say, 50 crore of peoples who are using this IT, 50 to 60 crore of peoples who are using this IT infrastructure. So a lot of data, you can assume that if multiplied by 100 bytes, then you can think of how many volume of data can be generated per second or per minute, or what's the time slice you take up. So there is, but obvious, a data mining is there. So analytics is again helping us to give a quick response and correct response in case of need. Say, and most important is that reviving the breakdowns. If my network fails, how can I revive my network as early as possible that a user do not understand that there was a breakup? There is a power failure. How quickly I can restore the power so that there is no real feeling of being breakouts. And being in a cloud, see, what problem with the AI is that as the data increases, AI analysis expands itself. And this particular expansion or requirement of resources, computing resources and memory, that can only be handled by using the cloud, because cloud can be scaled up easily and can be hired. And one of the major reasons of using the cloud is that the infrastructure companies must be separated from that soft service companies. Security is become no more issue for us because everything becomes the responsibility at the cloud. And with AI included, we have a better decision how optimally we can use our existing resources. You can see in COVID scenario what we actually mismanaged is the movement of these people. We could not anticipate the exact mobility of these or anticipate this kind of heavy unscheduled movement of the people, and that has caused us a lot of chaos. So the decision making could have been better if we are looking into the location of these cellular phones consistently, their source and destination, current destination. We can understand that there is a mobility and we would have been able to take a better decision. So decision making would have been different if we would be using this kind of infrastructure. Now, these are some of the platforms. Let me tell you, we are talking about AI in a very broader terms. But the fact is that, as you see from the list, there are the generic platforms that can be tuned, and there are ready-made tailored platforms that you can directly use for the specific purposes. Just Watson Studio, you can do for the IoT data analysis. IASD, that you can do for the business intelligence, WITS, text and speech. So you have many different AI platforms which are used for specific purposes. Besides Kubeflow, TensorFlow, Azure, they are journal. And to my I feel very great that for such a long time, we have the Indian companies, which is basically having their own platforms, but they are not publicly accessible. But still, we have platforms in India also. I hope soon these people will be opening us for the academics and for hiring, rental for the open public domain. Now, putting up a cloud is something not very feasible because it increases lot of data traffic over the network, because thousands of connectivity, thousands of things are being added. So to augment the computational capabilities of the cloud, what we are doing, we are putting up certain localized computations close to the cloud. So source which is generated. For example, say there is a industry wherein your mask and PPE kits are being manufactured. These machines' operational parameters are being monitored. Correct. Now, based on these parameters, the company is going to decide how much they are going to produce from one unit and how much they are going to produce from that another unit. Now, if this two data is pushed towards the cloud continuously, then that will create a lot of network traffic and cost to the company. So what they do, in case of local processing, they put up certain computers and storages. One of the cheap example will be the Raspberry Pi, which is often used in the medical industry as an edge node, can be put up to do the local processing, like triggering of high temperature notifications, triggering of oil levels within the machineries. That can be done by these edge machines. So this will help the cloud not to intervene, and simultaneously these edges will be telling the cloud, I have done this thing. So the clouds are updated with the action taken by the edge. So edge is not edge is computing, giving response to the system, as well as updating the cloud about the action taken and the data in the consequence of the action. Now, corresponding to this, to facilitate the same feeling, there is something called as mobile edge computing, where the software entities specifically for cloud-oriented operations through mobile phones, they are pushed towards the base stations. The services are pushed to the base stations where they may be easily accessible or be doing much better performance. It's a red screen. So it's happening like, so this is the edge computing. Though in edge, we have specialized hardware brought by us. In mobile age, the computational capabilities are at the tower. That is what the basic difference between the two. Now, again, depends how many services you are going to deploy, and everybody has to deploy the services for exploit the mobile edge computing. Now, this is something very different. Now, I have an edge for a machine. Now, these edge can be meshed up together using a Wi-Fi network to form a fog that act as an intermediary cloud for a large factory setup. If a factory is having a one workshop, then it's fine. But if a factory is having a multiple workshop, then each node, edge node, can be integrated together to produce an integrated view to the cloud of entire your workshop. Similarly, you can see, so what is happening? We have the 3 or 4 kind of cloud requirements, and these are independently handled by the interconnected edges at respective stations. So this again offloads the cloud, but cloud is again. So from here, what I can say, the next generation of computing can only be defined the domain where we are entering, the problem we are facing. We cannot look into European problem and solve from India, because India is having its own problems, its own kind of machinery, its own kind of people behavior and psychology. So we have to see the data. We have to see the local set of problems and the local set of resources and define the architecture for ourselves. Thank you.
Thank you so much, sir.
I look forward if some of the students of your college will be interested to work with mobile edge computing sort of thing with.
Yes,
I'll
sir.
be happy to
I will
work.
definitely share your contact number and your email ID to our students, sir, and they will definitely reach you, sir. And sir, it was
So
really
nice
a great experience for all of us, and to have a speaker like you, sir. It is really like we are getting new things like fog computing and new trends of research, sir. Thank you so much, sir, for sharing your knowledge, sir.
Thank you, sir.
So nice, sir. So nice of you. Thank you.
I would like to call Dr. Renu Singh, Madam, UP Head SP IIT Bombay. Are you listening, Madam?
Renu ma'am, are you there? I think ma'am is not connected right now. So moving on to our further speaker, I would like to call Engineer Vishal Verma, sir. Vishal sir, are you there?
Okay.
Yes, sir. Welcome, sir.
Most welcome, sir.
Okay, sorry, I was facing some problem while unmuting it, and looks like you have unmuted it. Thanks, everyone. And I hope everyone is safe in this situation and staying at home. So mostly I was just looking into that R.K. Mishra sir slide, and it's very informative in terms of if someone wants to make a career in cloud and artificial intelligence and machine learning. So that will be a very good starting point. And if someone wants to work, it's a very good career opportunity. So here I will not be talking about on the technical terms, like my agenda will be like how you can make yourself a job future ready or job ready. So as everyone knows, like we have tough times coming ahead, and industry-wise there is a job hiring as in frozen, but it's not like permanent. And we have 2-3 months before the hiring starts again. So to all the students, if you want to be job ready and you are looking for a better career opportunity, you have 3 to 4 golden months. You can utilize this time to learn the new technologies. And this is a time where you can decide like what you want to do, which domain you want to do. You want to do any sort of analytics, any business intelligence, any machine learning, any kind of DevOps, automation, all those things. So you have to start learning. if you go for an interview, there are a couple of basic requirements that anyone can expect from you. It's not like, okay, you have done your MCA, BTech, you have done all that, have all that practicals information you have, but there is a certain level of technical expertise that we expect while we take the interview. Just like, suppose you want to do something in the automation. So I'm going to ask you, what kind of programming language do you need? Do you need the Perl? Do you know shell scripting or Python? So I don't expect anyone to be expert at that time, but at least you should be knowing that, okay, what is this Python? How do we start? What is this shell scripting? Most of us might have done some small projects in this during that your Viva or your programming classes and tutorials. But this is a time that you leverage this time and enhance those skills to the next level. And coming to the next generation technologies where you can make your career. So I have just a list of few technologies like automation. How you're going to do the automation? You need some tools. So go and identify, search those tools. So next question comes, sir, I have done all that. Just one second. So I have completed my course. I have done the CC programming classes, but for me, that might not be enough. Search, like create an account online and do some kind of POCs, try to create a programs, applications. It may not be at expert level, at least you have something to show in your resume, right? So because there are hundreds of people when you go for interviews, so someone has to shortlist. I need 10 resources. I have only 10 openings. How do I select you from those 100? So I have to be on that first 10. Okay. Next is like DevOps. It's an emerging technology that we are looking for. Python. Python is a very good tool to start with the automation. If you want to learn the Python, it's not very rocket science or it's stuff. It's just you need that basic computer knowledge. And the resources are available online. And there are like free videos, tutorials. Go and search how to learn Python. Just simply have to write in on YouTube. You will be finding lots of classes. People are just training very nicely. If you want to go for some paid classes, like there are some examples of udemy.com, go purchase some courses. One course will cost hardly 400, 500 rupees. And you can watch it, download it, and you can do the practice as well. But if you say, okay, you have completed this training, like you know at least suppose for the Python or machine learning basics, if like Sir R.K. Mishra sir was saying, informing about the cloud technologies. So similarly, we have the cloud, like AWS is a cloud provider, Oracle Cloud Infrastructure is a cloud provider. So just knowing the name is not enough. At least you know what is the AWS, what is the use cases, and where to start with. So simply you can go and create an account on AWS, Amazon Web Services, get one training video on Udemy or YouTube, learn them, do the installations, create a machines, do the analysis, scrap it, do everything that what you want, and note down your learnings. Okay. And second thing is, how do you know what is upcoming in the market? So everyone is in, I hope in UP, Faizabad. So sometimes the challenge is that we don't know what is upcoming in the market, what kind of job opportunities are coming in the market, right? When you go for an interview, then you know, okay, interviewer asking this question, but I haven't learned it. And this is a job requirement, but I have expertise on this particular area. So first you have to know what is coming 6 months down the road. What the companies are looking for. Go create one account. Everyone has a Facebook account. Similarly, create a professional account on LinkedIn. Try to see what people are doing. You can find that what people are doing at from your college or other universities, if you are from electrical engineering background or mechanical engineering background. So you can just find out what people are knows of those technologies. Try to explore them. Go and connect with them and have a chat with them, get the contact details from them, talk to them. Anyone will be able to help you on that area. So be ready and utilize these 3 to 4 months that you have, and wish you good luck and be safe. Thank you.
Thank you, sir.
And then thanks to all the professors. And just I knew about this web conference, and thanks to my colleagues Rajiv and all that honorable professors of IT, and to just start this initiative. And I'm sure this is going to help all the students of IT and university as well. Thank you. And if you need any help, like if you want to talk further, you can just get the contact details from Rajiv, and I shall be able to help or guide further. Thank you, everyone.
Thank you, sir.
Okay, so I think it was a great day for all of us in perspective of our knowledge. We gained so many things and so many research areas from our eminent speakers. And now we are about to close this webinar based on next generation computing system. So moving on to the validatory session, I would like to request our Honorable Director, Sir, Professor Ramapati Mishra ji, to proceed, sir. Thank you, sir.
Okay, thank you so much, Engineer Manisha ji, Head of Department, and my dear colleagues, wise speakers. They have delivered knowledge to my students, faculty members, and participants in this seminar, e-seminar rather I will say. वेबिनार से भी मैं बचता हूं क्योंकि वेबिनार एक तरफा होता है. ई सेमिनार्स में आई थिंक माय ऑडियंस विल एग्री विद मी कि हमने पूजन भी किया है, हमने अपना कुलगीत भी किया है, और हम एक दूसरे को फेस टू फेस देख पाते हैं जैसे एक ऑडिटोरियम में करते हैं. बस प्लेटफॉर्म यूज्ड इज इलेक्ट्रॉनिक मीडिया. सो इट्स ई सेमिनार. Nearly started with 270 participants on our Zoom connection and more than 600 participants on Facebook Live listening to us. A very good thought-provoking lectures have been done, notably starting with Dr. Talal Yusuf from Australia. He is dealing with online education and he has taught us to research on AI-based online education. So मुझे जो लगता है कि जो हमारे बीच में फैकल्टीज हैं वो जान जाएं कि रोबोट भी पढ़ा सकेगा आगे. रोबोट आर्टिफिशियल इंटेलिजेंस की मदद से ऑनलाइन क्लास ले सकेगा. डॉक्टर करण सिंह talked on security implementation in wireless multicast systems. Dr. Anshul Verma, he talked about opportunistic network and delay tolerant networks. Engineer Piyush Tiwari from USA talked on cloud computing and soft computing. Engineer Shivam Tyagi, he has enlightened us on the research areas in energy and security sectors in the next generation. Then Dr. Anupam Singh talked about blockchain technology of future, which is likely to emerge. Professor Narendra Kohli sir from HBTU talked about very interesting topic, human brain interface. इसको बहुत ज़्यादा मिलने जा रहा है तवज्जो. ये एरिया एक डोरमेंट है जिसमें बहुत काम बाकी है. डॉक्टर अनामिका सिंह रिसर्च स्कोप इन ई एजुकेशन पर, क्योंकि ये फ्यूचर की मार्केट है. वी हैव टू लिव विद कोविड. कोविड हम सभी लोग जानते हैं कि जल्दी जाएगा भी नहीं, और जीना है तो ऑनलाइन एजुकेशन और ई एजुकेशन को ही हम लोग प्रमोट करेंगे. डॉक्टर राकेश मिश्रा सर का बहुत अच्छा जो रहा है वो क्लाउड एंड एआई प्लेटफॉर्म्स फॉर टेलीकम्युनिकेशन रहा है नेक्स्ट जनरेशन के लिए. हम लोगों के बीच में डॉक्टर सुदीप तनवर सर निर्मा इंस्टीट्यूट से आ रहे थे, बहुत अच्छे पॉइंट उठाए उन्होंने। हेल्थ केयर सिस्टम में रोल ऑफ एआई इन पैंडेमिक, रोल ऑफ अनमैन्ड एरियल व्हीकल्स। अब देखिए, जब ह्यूमन टू ह्यूमन टच को अवॉइड करना है तो अनमैन्ड एरियल व्हीकल्स हैव टू कम like quadcopters to deliver the items home to home. Engineer Vishal Verma, he guided making job future ready. Recession आ चुका है, स्किल बेस्ड एजुकेशन लेकर के हमारे स्टूडेंट्स, हम लोग भी फिर से वी कैन बी मार्केट रेडी। जो पूरा इमर्ज हो करके आ रहा है, और जब हम कंपेयर करते हैं और भी रिसर्चर्स ने जो आर्टिकल्स वगैरह पब्लिश किए हैं, तो फ्रॉम दिस कॉन्फ्रेंस आल्सो इट कम्स आउट दैट मोस्ट इंपॉर्टेंट सेक्टर्स आर फॉर द नेक्स्ट जनरेशन कंप्यूटिंग सिस्टम, एजुकेशन सेक्टर, energy sector, community health care, जैसे telemedicine we have to deal with, exploiting, optimizing artificial intelligence. Community health can be looked after by digital means using employing artificial intelligence. Of course, financial sectors are always based on computing, and day by day its security features are improving. Based on AI, we will be able to make it more and more secure payments. Then biosciences have been described. It was the topic of Dr. Sudeep Tanwar, who could not be connected. But then biosciences में भी हम लोगों की बेस्ड ऑन नेक्स्ट जनरेशन कंप्यूटिंग सिस्टम दखल रहेगी, रिसर्चेज रहेंगे। आई फाउंड दिस वर्कशॉप वेरी यूजफुल। एज ए डायरेक्टर आईटी, आई एम प्राउड ऑफ माय एमसीए टीम हेडेड बाय डॉक्टर ब्रजेश भारद्वाज। अमित भास्कर जी भी हैं, अपने इंजीनियर राजीव कुमार जी भी हैं, इंजीनियर अखिलेश मौर्य भी हैं। रियली वेल डन, सुपर्ब जॉब। एंड फाइनली आई एक्सप्रेस माय डीप सेंस ऑफ ग्रेटिट्यूड टू द स्पीकर्स एंड द पार्टिसिपेंट्स who joined us from the far-flung areas. Maybe due to internet connectivity also, they faced problem. But ultimately, till this time, that is 3:29, 3:30, you are with me. I thank you from the core of my heart. Thank you so much. Over to you.
Thank you so much, sir.
Thank you, sir.
For your valuable time. Now, in this valedictory session, now I would like to call Dr. Brijesh Bharadwaj, sir. Sir is head of MCA department. For vote of thanks, sir.
Thank you, madam. Best regard all of you. Good afternoon. Honorable Vice Chancellor Professor Manoj Dixit sir, Pro Vice Chancellor Professor S.N. Shukla sir, Dean of Commerce Professor Ashok Shukla sir, Director IT Professor R.P. Misra sir, all speakers, ladies and gentlemen, faculty members, and dear students. I thank the Vice Chancellor Professor Manoj Dixit sir, who gave us his valuable time and show the path of the all of us with his blessing words. The Honorable Vice Chancellor has always taught of us to move forward and show the impossible well as possible with his outspoken personality and outstanding work. I thank you, from the depth of my heart. I thank the Professor S.N. Shukla sir and Dean of Commerce Ashok Shukla sir. You are always encouraged by us. Statements made by you from time to time increase our ability to do work. Thank you very much, sir. I thank Director sir, Professor R.P. Misra sir, who always try to innovate and encourage all of us. You have taught us to be disciplined and regular in life. I am grateful to many experts who have come share their knowledge in the international webinar on next generation computing system. The experts are Dr. Anshul Verma, BHU Banarsi, Dr. Karan Singh, JNU New Delhi, Dr. Narendra Kohli, HBTU Kanpur, Engineer Piyush Tiwari, eBay USA, Engineer Shivam Tyagi, St. Joseph University USA, Dr. Sudeep Tanwar, Nirma University Ahmedabad, Engineer Anupam Singh, UPSC Dehradun, Dr. Anamika Sinha, Assistant Director IGNOU Lucknow, Dr. Renu Singh, SP IIT Bombay, Dr. Rakesh Misra, FGIT Raebareli, Dr. Talal Yusuf, Professor and Pro Vice Chancellor, International Federation University, Australia, Engineer Piyush Singh, and Engineer Vishal Verma, Software Expert, Bangalore. I take all the experts, speakers who brought about the next generation computing system. The way in which this topic was explained by you is exemplary. This has certainly enhanced the knowledge of research scholar and participant. Thank you very much, all of you, sir and madam. I thank all the faculty members, member of organizing committee, whose tireless effort made by the webinar a success. I express my thanks mainly to Raju Kumar, Ramesh Misra, Engineer Partosh Tripathi, Engineer Manisha Yadav, and Akhilesh Kumar, who played an important role in organizing this webinar. Thank a lot once again to all of you. Jai Hind, Jai Bharat.
अपने बीच में प्रोफेसर अशोक शुक्ला सर भी आ गए हैं. जस्ट नाउ आए हुए हैं सर. प्रोफेसर अशोक शुक्ला सर को मैं
Yes, sir. Ashok Shukla sir is connected now, sir. Sir,
Professor
are you able to hear
Shukla,
us, sir?
he is a very senior professor. He has been mentor and guide for us, and currently he is director of IQAC, high-powered academic body of university. Honorable Professor Ashok Shukla sir.
Sir, audio connect nahi sir.
Sir, I think there is some network issue. Sir is not connected via audio, sir.
Okay.
So now I would like to end this session on behalf of all the IEP fraternity and Dr. Ram Manohar Lohia, Awadh University Ayodhya. I would like to thank all the speakers, professors, and resource person for giving your valuable time. Thank you so much all. Now we are ending this session. Thank you so much.
Ready for Rashtragan? Now all of you ready for national anthem? अखिलेश जी.
जनगण मन अधिनायक जय है भारत सिंध गुजरात
मराठा द्राविड़ उत्कल बंग विंध्य हिमाचल यमुना गंगा उत्कल जगत तरंगा तब शुभ नामे जागे तब शुभ नाम मांगे गाए तब जय गाथा जन गण मंगल नायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 जय
भारत माता की भारत माता की
जय
भारत माता की
जय
Thank you so much, sir. Now we are ending this session.
मनीषा मैडम वो सर्टिफिकेट के लिए
Yes, sir.
सर्टिफिकेट फीडबैक फॉर्म
Yes, sir. We will share a feedback form to every participant and speaker. So please share your valuable feedback to us. And certificates will be provided to you within 2 or 3 days on your email ID, sir.
Thank you, madam. Thank you, all of you. Thank you, director, sir.